people, hand raise. There's a more button. Okay, there you go.
Oh yeah. No, I got it. I just said I'm trying to just remind myself to do it. I don't. Can I decouple the transcription? There we go. Yes. Okay, that's what I need. So all right. So we'll get these sessions recorded, and then let's see here. Next, I'll go ahead and share my screen here so everyone can see the training manual there now on your screen. And I'm going to let's see here. I'm going to go ahead and turn off not sure how to do it for you guys, but go ahead and just turn off the videos just to save a little bit of bandwidth. Not that it matters a whole lot. Give it my transcript, and let's see, what else do I need? Okay, so everyone can still hear me okay? Let's see, turn off and teleframe. There we go. Maybe. Well, I don't know. Okay, so there's, I can't seem to get that video part off now. Let's see here.
Is it a Teams issue, Ken, or is it a video that's part of your content?
No, I was trying to turn off the Orlando has a video running. I was just going to mute their camera, if you will, just to save a little bandwidth. It won't hurt anything. Leave it on. That's no problem. And then
Rodney, can you turn your camera off?
It's
we don't want to see your ugly mug here all day.
I can't, like my personal camera?
No, the conference, the one that's at the end of the conference room, but
I want to see us.
There we go. Now,
okay.
The next one is I can't see me. Looks like I'm still on camera. Is that correct?
Yeah.
And I don't see my panel in the main screen. Raise reaction. There we go. Now, is there no camera off control here?
There should be. If you have a microphone button that's on, there should be.
Yeah.
There's usually a camera button right next to it that you can just kind of
There is.
Toggle on and off.
Well, if I choose that, it just, oh,
There you go. You're gone.
it toggles it. There's a pull down that has the options, but the toggle is just by pressing it. There we go. I see. All right. There we go. So now, apologies and thanks for the guidance through the swamp there, folks. All right. So, again, like I said, and I'll jump ahead down there a little bit. You can read a little bit about, my background, although this over 30 years is now getting to be over 40 years. So you can get an idea of, some of the type of things that I've done, but I've done mostly in the training for Carlson has been in survey and civil solutions, and as they also apply to the construction industry as well, because there's a slight different approach sometimes as we prep things for construction, although it really, when you're prepping things for construction, in terms of building surfaces and things that you could put on your machinery to do your automatic, your GPS, machine guidance, those need to be modeled, very accurately and correctly. But in terms of building estimates and earthworks and material quantities, doing the takeoff of a set of plans, there's a slightly different approach to that, and we'll talk about that as we go through it. And it's see, does anybody know? Do any of you have the actual construction module, or do you have civil? What do you normally use out of your Carlson software?
Construction module, it sounds like, yeah.
Okay, so
we have
you
a combination of things, Ken.
Yeah.
Estimating uses construction, the takeoff stuff, and then we own the civil suite, survey, point cloud, all that stuff. But this one, as you know, is focused hopefully on the estimating side of things.
Yeah. Okay. So you actually have the full takeoff product. So that's what I was curious about to see, because and civil has a sort of a subset of that, in case you're ever looked at it. And we'll see it as we touch on civil a little bit. But it has a menu called SiteNet, and that's basically sort of the construction module, at least the estimating portion of it, with a few, I won't say limitations, but a few things that it doesn't do that its big brother, the construction module, does, particularly in terms of color and visibility. So we'll take a look at that so you can see, in case somebody should maybe not have access to construction, you can still do this same type work under SiteNet. And that, like I said, it's just a slightly different approach, and it's basically in how you identify the things that are going to be built into the model. In the, let's call it the civil approach, or the non-materials or takeoff approach, is going to be to identify things in the drawing by selection, whereas the takeoff approach, or the construction or SiteNet approach, is going to be to identify those things that are going to be part of the model based on the layers that they are drawn on. And also, that relies a lot more heavily on things being closed polylines, so that you can assign material thicknesses within the outlines of that closed polyline. So you'll come to recognize it when we get to that point. And so it all, shares things back and forth. Everything's all done the same way with the same actual algorithms behind the scenes. It's just a matter of how we set the stage. And a big part of what we're going to be going over for these 3 days, and particularly the the day 2 and 3 of next week is going to be really kind of focusing and fine tuning those modeling capabilities and understanding so that we can really get some good clarity on building those models so that they're exact. So, you should be able to take a set of plans you get from somebody, or even if you're designing your own, obviously that's you have control over that from the start. But you can even take a set of plans and turn that into a model that's so exact that you should be able to, a robot should be able to build it. I mean, you can include stairs and even stair railings and all of the things that you don't even really need to build to be able to construct a site. But certainly we've got the tools to do it. And I want you all to have the understanding of how that part is done. Okay, so first things first, let me get an idea of how many in the room. I want to get a sense of, where we are on the experience or the experience spectrum in terms of two things. One, in terms of AutoCAD or IntelliCAD, if that's what you have, and also in terms of Carlson. Like, we're all just, we all just started working here last week, and we've never seen this before. I just learned how to spell CAD, or, I've been doing this for 20 years and using Carlson for the last 10 years, and I just want to brush up on my skills. So I know there's going to be a range of that, but can somebody either speak to that, or maybe we could all just go through it and let me know so I know about the pace to push the class.
I guess, I don't know, Rob, I would say as on an average here in Florida, we're probably a 3 or a 4 out of 10. Arslan and Bruce being our two top users.
Okay. And
Yeah.
that's familiarity with the Carlson product as well as the CAD engine underneath.
I would say, yeah, maybe it's a 3, but close.
Okay. So
I think I'm not sure if I'm alone in this, but I have 0 CAD experience and very little Carlson software experience. I've played with other earthwork softwares before, but not Carlson.
Something like ag tech or things like that.
Ag tech, exactly. Yeah.
Oh, okay. Well, that's good to know. I'm glad you come from that background, because Carlson construction, if you've not noticed it yet, the actual construction module itself and what Carlson's standalone version of that module is called Carlson Takeoff. That was actually developed and brought to market in direct response to the ag tech product that was out there as a competing product. Certainly you could do surveying and civil engineering design and hydrology and all those different things independently, and mining as well. But the ag tech product was really what sort of spurred that development. But again, and you're going to see some, depending on the level of familiarity you have with ag tech. And frankly, I don't have much myself, just, high level awareness of it and what it can do. But you're going to see a lot of, I think, some overlap, or not really overlap, but similarity in how things function. But again, it's going to be centered around an AutoCAD drawing file. So that'll work for that. So anybody else different?
Me,
spectrum?
I have none and none.
Okay.
How's that?
That's perfect. I need to know that so that when we're talking about drawing a line, we can make sure you see where we get the tool. I can't just say, draw a polyline, and next you're going to take this and do that. I got to make sure that you're aware of how to draw a line and what a polyline is in a circle. And piece of text. So that's exactly why I'm asking these questions, is to see where to go from. All right. So as I was thinking, we've got a bit of a spectrum there, so I'll try to do it now. Let me ask you all something as well. If, as we're going through something, I happen to rush past something that maybe is second nature to me, and I don't think about it, and the one thing is, I don't want you to get frustrated when that happens. I do want you to take a little bit of encouragement to know that you'll get that way. You'll get to the point where you don't even think about this stuff and it'll happen. But what I do want you to do is, if that happens, to stop me. Just go ahead and unmute the mic and say, oh, hey, wait, can you show me where? So that we make sure we get that covered, okay? So make sure that you can do that. Now, one other question in terms of what you have software-wise. Does anybody know, or is anybody running the actual takeoff? It's a standalone project. It would be called, like, you'll hear it referred to as like R10, R11, R12. And it's a product that actually on the desktop icon, it says takeoff on it. It doesn't say Carlson Construction. Is anybody running that? Okay. So we're all going to be.
I don't think that'll be the case, Ken.
Yeah, so we're all going to be on the modular CAD side. Now, what about the CAD platform that we are running this on? Are we doing this on top of AutoCAD or on top of IntelliCAD, or a mix?
Everybody should be running IntelliCAD in this group.
Okay. Yeah. All right, so that'll be what we do. I've got both platforms, and they're not really. I mean, they're barely. They're almost indistinguishable. I actually happen to prefer the IntelliCAD version myself. I've been using AutoCAD since before it was a commercial product. It was in beta test way back down in Atlanta years ago. John Walker took it to a trade show, and it was, so I've been with it for a long time. But IntelliCAD, in my opinion, is better now. And it's because it doesn't have so much bloat in it. And AutoCAD itself will actually crash a lot more often than IntelliCAD does, based on, certain things it might read in memory or what. But anyway, we're not going to get into the philosophy of that. So let's talk about what we do have here in front of us then. So you see a little bit about, again, my experience, but the important thing I want you to take away from this first paragraph is this right here, that email address. And that email address, keep that handy after the training's done, because whenever you become an MSoft training client, you then have access to us, and specifically to me, as technical support on the software itself. Now, you always have access to Carlson technical support, and they're really good, and they get back to you very quickly. I have found they're very helpful and client focused and client supportive, customer supportive. One thing, though, that I can offer sometimes that a room full of programmers can't necessarily, is the fact that I've been an engineer for 42 years. I've been doing this stuff since we've had computers brought into the room. So, and I've got a pretty good affinity for this. I'm also a certified instructor for the Bentley series of software that's now culminated in the Open Roads product, the Autodesk with Civil 3D, and then, of course, Carlson. Carlson remains, to me, the more straightforward approach to this type of modeling, but they all share the same sort of fundamental steps toward creating a three-dimensional model that we can then either present or query or analyze, and then try to get that out into the field and get that recreated in the field, whether we're surveying a bunch of points from a road alignment or whether we're, doing the subgrade excavation for a commercial building site. Anything and everything that we do out on the ground all comes from this development inside, our model building and our understanding of that model building. And so that's the advantage that I can offer is I've done that. I've been on the engineering side of the picture where I've seen engineers deliver a project by means of, say, a set of drawings and specifications. The contractor gets them, he bids on them. The engineer then, usually assists the client in helping to select that contractor based on that bid, based on the engineer's understanding. And then they turn them loose on the project, and then the RFIs start. Okay. Well, that's no fun for the engineers, nor is it fun for the contractors, because anytime you have to request, more information on something, that means something wasn't clear. Now, I've seen this attitude in the engineering side of that picture where the engineers they get very defensive sometimes. And they said, well, no, we gave them what they need. They don't need, everything they need is right there on the drawings. They don't need anything else, that we can do it. So, well, we can clarify, but so that's one approach. The other approach might be something like, well, the contractor knows what we mean. I've heard that. In fact, here I'm located in Pittsburgh, by the way, and the city of Pittsburgh, the actual city government, for instance, when they lay out water lines and sewer lines down in the city, they don't even bother with, surveying in the actual, any kind of a street center line or a construction baseline. It's all based on the street right of way, and all of their drawings are on a 5x5 grid. They've got actually blue line gridded paper in a 11x17 pad that these guys walk around and do this to sign on. And my complaint when I first got here, I said, well, that's not, it doesn't go straight. It's not exactly parallel to that. Well, the contractor knows what we mean. And so then they hand it all off on you poor guys to try to fix. Okay, so that's what I'm trying through my educational outreach to rectify, is to get everybody on the same page and realize we're all working to make this a success. I'm tired of engineers hiding behind, this excuse of liability with big quotes around it, as a means of, not sharing their information, not working with the whole team. Because they'll say, oh, well, they may change my design. Well, yeah, they're going to change your design if you don't give them what you meant, because they have to try to interpret it and they have to build it up all over again. Now, this particular scenario is not going to change tomorrow. In fact, it won't change, until after I'm retired and probably dead and gone many decades. But anyway, I feel your pain. So that's the point behind this email address and the contact information. Pick up the phone and call me. I do work on other things. I do have other training projects. I do have other actual design and consulting projects as well. But keep that handy, so you've always got access to me there. Even if it's not something that we went over in class, it might be a question that you have. You say, hey, I saw this. I wondered about that. We'll do that as part of, your legacy as a client of MSoft. We also do things like, in fact, I'm finishing up a project right now, and it's a large estimating project where a construction company here in central Pennsylvania is bidding on a big solar, I guess you call it a solar panel farm. something like, I forget, 700 some acres of these solar panels that are spread all over the place, and access roads that wind their way back and forth in between them, multiple ponds and stuff. And so, they actually hired us on a T&M basis to come in and help look over their shoulder as he's starting to build his estimating from that. So that's sort of an extension of that training. So if it gets into large, very complicated, time-consuming projects, then we can certainly do, that. But if it's a simple 1 or 2 hour, 3 or 4 hour, one day kind of question, then that part's always covered. So anyway, that's about that. Now, here is basically, let me go down to this book, just a little bit about the nomenclature. There's not too many of these that are IntelliCAD versus AutoCAD specific, but here's a couple of little icons to keep your eyes open for in the book. You'll see these things, and they're sort of, these good ideas or important things to take note of. And so you'll see them, just on the side of some of these documents. Say, like here on page 10, there's a little tip. Okay, so that's really about that. And here now is sort of, and again, we don't need, I'm not going to read this to you, but what's going on with your Carlson software is sort of summed up right here on page 3. Tells you about that. Way the Carlson software works is it's basically a system that sits between you and IntelliCAD or AutoCAD, some kind of a CAD engine. Now, the CAD engine, on its part, it doesn't know or care what you are doing. It doesn't know or care that you're building a road or a building site. It doesn't know or care whether you're drawing printed circuit boards or maybe fashion patterns to put on a CNC machine or an automatic embroidery machine. It doesn't care. It just deals with drawn objects. Okay. So we, however, as engineers and surveyors and construction people, we have a certain way that we think about things. We know about roads, then roads have straight line pieces we call tangents. They have curves we call curves. They have PCs and PTs and PIs. So we have our own little arcane language with dealing with stuff. So Carlson is going to sit between us and the CAD system. It's going to talk to us in our terms, gather up what it needs, and then it's going to turn around behind the curtain and talk to AutoCAD or IntelliCAD in the X's and Y's and Z's, give it what it needs to get produced, what we can see, and then it takes those results and turns around and gives them back to us, takes the XYZ and turns them into northing, easting, and elevation, if you will. So that's really the process that's going on. So you don't even really need to know the underlying CAD system in a great deal of detail. You don't need decades of experience to do that, to be able to run the Carlson software. You just need to know where the tools are that do what you need to do. And that's what we're here to do in these 3 days. So let's take a look next back here in our manual. We're, as we start the table of contents, and if you have not noticed this already, the table of contents is hyperlinked. You can come down here and find a particular subject you're looking at. For instance, down here on this page 48, merging the surfaces as part of this final exercise of putting it all together. in the fundamentals section. You click that, it goes right to that particular thing. Now, there's not a back button. It's not like, web navigation. You can always come back up to this, but it will help you get to these different things quicker. The exercises that are outlined in the book, and they tend to be enumerated. Like here's one exercise for point groups. There's a, point, step 1, step 2, step 3, that kind of stuff, and then discussion 4 and 5. So the exercises are going to be where you're going to get things reinforced as well. Okay. Now we have a couple of things or sort of a bifurcation, if you will, of this manual into what I'm going to refer to as fundamentals and then more detailed. And the fundamental part, and I'm back here on the first table of contents page, and it talks a little bit about this and Carlson software and how the work gets stored, where things are going to go. We'll look at that when we get into the software. And then there's this what's on the menu. There's this thing called general versus modular menus. Now, this does not, at this section, go into detail about what each of these menus does. You can see I talk about the first, the general menus, and then the file menu and edit menus on page 7, then draw, inquiry, settings, and points are all on page 8. And there is, yes, indeed, we left out the view menu, but it's actually in the content. It got left out of the table of contents for whatever reason. So that's going to be a little generalized discussion about these general menus. We'll talk about that in a minute, but it goes from file, edit, view, draw, inquiry, settings, and points. Every Carlson software module, whether it's construction, mining, GIS, civil survey, trenching, CADNet, any of those, they all have those same first 7 menus: file, edit, view, draw, inquiry, settings, and points. It's what comes after the points menu where you get into these modular specific menus. And so that's what this whole section here, and I just went on to this what's on the menu bit, talked about general versus modular. There's file, edit, view, draw, inquiry, settings, and points. Anything after that is the modular. So here's our general, here's our file menu, here's the edit menu. You sort of get a sense of, from what the menus are called, what they do, what they're going to contain, tools to draw things with. On the inquiry menu, tools that are going to help you analyze things in the drawing, to ask questions about it. Settings, okay, they sort of self-explanatory. Points, that's going to be a big one if you're dealing with points and working with points. Sometimes we do, sometimes we don't necessarily have to. So from that, though, we go into these modular menus, and if you look at this next page, on page 9, it gives you an example of each of these different modules has these additional menus beyond points. The survey module then starts with survey, COGO, centerline. You get the idea. Civil is going to have 3D data. Now, 3D data in the civil menu is going to be a lot of the same commands that you're going to see on the construction module. It has an elevate menu. So those are going to be a lot of overlap. A lot of the same commands are going to be found in both of those different products. And in the civil module menus, there is a SiteNet menu that basically has the same functionality or a portion of the same functionality that in your construction module you have on your takeoff menu. That's where you're going to see things like, select your bounding polylines, select design, so select existing entities, select design entities, then make existing, ground, make, design, surface, all of those different commands are all going to be the same. Now, construction then also has on its self, it has a roads menu, and its roads menu is sort of a subset of what civil has. It has roads, which has even more commands than roads under construction does, but in addition to that, it has all of these different things that make up road design. It's got centerline, has an entire menu by itself, profiles has an entire menu by itself, cross sections, and then roads is the actual processing part of that. Everything in construction, though, is contained under roads, and it has enough tools out of the big brother civil to get that road designed and built the way it's supposed to go. So you see how there's a lot of overlap back and forth, and you can do some of the same things in multiple modules. Notice survey, civil, construction, hydrology, they all have a surface menu. Some are smaller, some are more extensive. So just a matter of where these things are. Okay, so with that in mind, we're going to try to peel back the curtain and learn what these do. Now, like I said, these little discussions up front here where we just give you a little paragraph about what these menus do. To find out what these menus really do, all of the details, I'm going to come back to my table of contents, and I'm going to see, after that little discussion there, we go into our build up here and our important concepts and our exercises. Then we go to this civil, whoops, sorry, I didn't mean to click that. So then the next page, we go to this civil module design where we start working on roadway designs and grading tools. And then when that set of exercises is done, there is this section called command reference, general menus. And there you see file, edit, view, draw, inquiry, setting points. And then the civil menus, 3D data, surface, SiteNet, etc. You go there, and I'll switch to that command reference, general menus. And here's where the entire menu is going to be shown and explained. I say the entire menu, there's an asterisk by that word entire. And one of those, let me get to, I guess here. In this little paragraph is that the edit menu holds a lot of the standard CAD tools that, if you're familiar with AutoCAD at all, you might be, leaning on those, how to edit, move, copy, break, offset, all these different types of tools that you might want to do, and they tend to be on the edit menu. They tend to be fundamental in the sense that they're working just on these CAD drawings. If you're doing something that's very model specific, you're going to find that on some of those later module type commands and the different menus there. But because this edit menu has a lot of these standard CAD editing tools like move, copy, trim, rotate, and then the others have similar names, but they've been enhanced with some additional functionality. What one class of mine years ago, one guy said he called them Carlsonifications of the CAD commands. And so that's where they're presented. You're going to see things like this erase by layer. Okay, it's not a command that's part of standard AutoCAD, but it's a command that has a lot of functionality that Carlson has built into it. So the way the rest of this sort of command listing or command, what do you call it, a glossary, or as you go through each of these menus, is going to be with this particular caveat when in terms of talking about the entire menu. is that some of these are, like I said, standard CAD commands. And so right here, the following section, and that's, true for all of these menus, it highlights these Carlson enhancements to the standard CAD tools. And so if you don't see it in the list down here below, then that means it's just a standard CAD tool. So if you look at the little snippet of this menu that's here, this is the edit menu, and there's undo, redo, clipboard, which has the, cut, copy, paste type of things in it. And so those are all just standard CAD tools. They have no bearing on the fact that you're running under Carlson. The first command that you get to that is actually Carlson modified is the erase command, pull right, select single last, then erase by layer. Okay. So that's going to be the first one that you see there. And then there's erase by closed polyline. Get the idea, erase outside, temporary erase. Now, it brings up another little point to make about the book. When you see the command highlighted, it's bold and it's in red text. Some of these others are not, like temporary erase, copy to layer. There's nothing to take away from that other than this. Those are commands that I, being the principal author of this textbook, have found over time to be really helpful and really productive types of commands that really help your workflow be a lot more efficient. That's all it is. It's purely subjective. You may, and depending on what you do with the software, what your particular role is, you may never need to use erase by layer. I use it all the time because a lot of my design process is iterative, and I'll try something, look at it, it doesn't work. Well, I want to get rid of what got generated and try it again with some different parameters. That erase by layer is a real time saver, so I don't have to go collect up a bunch of stuff that just got generated. And once I build that list, I just hit the button and the list stays populated. Okay. Likewise, you come down to temporary erase, you see it's not highlighted at all, and I'll tell you that's it's actually a dangerous command. See, what it does is that it lets you select certain things in the drawing and erase them, but it keeps track of them sort of in a history. And to unerase them, to put them back, you run the command again. You run temporary erase again to signify unerase. It's one of the least intuitive commands I think the software has. And again, it's very dangerous because if you do it and then forget to unerase them, if you save the drawing and exit it and go out, and then you come back into it tomorrow or an hour from then, those things are gone for good. There's no way of getting those back because wherever they go out into limbo, they're gone. I think, they may have fixed that. I'm not interested in doing it. I never run the command. That's not to say you shouldn't run it. If it makes sense for you, then, help yourself. But that's basically it on the manual. And so you can see all of these general menus: file, edit, view, draw, inquiry, settings and points. And then you get into the specifics under civil. There's your 3D data menu. Okay, 2D to 3D by surface model, by screen entities. These are all very good tools, and you can see the three I've found most useful out of these others, although they're all good. Couple things to take note of: reference elevation, the program prompting for well, if I can get this to settle down, existing surface triangulation files to compare blah, blah, blah. Let's see, steeper slopes in cut than fill. Oh, that's this elevate by grade rules, elevate building pads by grade rules. So it allows you to have variable slopes on those. So you get the idea of what all this does. And so, that 3D data menu, you can see how extensive it is. It starts here and it runs, whoops, over to here to where the surface menu then picks up next. Okay. And then triangulating contours. So there's all kinds of, little examples, explanations, little sketches and drawings that should go to explain those particular commands. Now, one thing the astute among you might recognize is that a lot of this stuff looks like it comes right out of the help system, and true, some of it does. Some of it in the help system, though, is pages and pages and pages long, so it's been pared down to basically the gist of what it is you need to walk away understanding, or there's not really enough explanation in the in the help system, and so this is expanded upon a little bit here as well. Regardless of any of that, the one benefit is this is a nice, smallish kind of document you can keep handy. You can print these out and keep them bound in a notebook on your bookshelf, or you can just have it available to pop up and refer to, to really use it as it is intended. It is a training guide. It is not going to be a step-by-step instructions for getting through the class. Okay, we're going to use it with a lot of, I guess, awareness of what it is that it's going to do for us. Okay, so we'll start into that particular thing. I'll come back here to the beginning, and then we want to really start talking about settings. So I'm going to be on page 10 of the manual. And this is going to be, how can I say this nicely? This is going to be a crushingly boring little part of the training. Okay. And it's going to be a little painful, but it's very important, though, that you understand how these settings work, not just how they work on your machine, but how the settings on your machine working on a drawing, let's call it, abc.dwg. And then that drawing is later worked on somebody else's machine that has independent settings for that machine. And then they pick up the ball and start working on their portion of working on abc.dwg. So the settings can vary, and certain things can be built with certain settings on when one person did it. Other things of that same type can then be further built with those settings turned off on somebody else's machine. And what happens is these settings are going to affect the behavior of things that are created in the drawing. And other things as well that settings typically take care of. But for the most part, and this is the part that's so important to understand, is that whatever state that particular setting was in at the time that the entity or object or label or whatever it is was created is going to be the way that thing behaves for everybody, regardless of what their settings are. And we'll see, some examples of that when we jump into the software. So really the important takeaway from that is to either just, remain hyper aware of it, but the only other way around this thing is that you can share your settings among all the users. If you store your settings in a centralized network location, that other users can then load those same settings, and the effect then will be, that regardless of the machine that something was created or generated on, the settings are going to remain the same. That's why if you see in that picture, that first dialogue or diagram there, down at the bottom, there are these two buttons. One says load, one says save as, and you'll see that on the bottom of many, many dialog boxes. And what they're intended to do is that once you get all these settings, as Goldilocks would say, just right, then save them, give them a name, put them where everybody else can share them. Okay. And then you can load. For instance, in my world, because I do design work and I do design work for various clients, sometimes state DOTs, sometimes simple commercial development, I may have certain CAD standards that I have to, create my work on for deliverable. I may have certain text sizes and fonts and things like that. So all of those things go into these settings and these dialogues. So once I get them all set up for, say, working on something for the Pennsylvania Department of Transportation, I'll save those Office PennDOT standards. I may have something else that the Pittsburgh Water and Sewer Authority might require. I'll do the same thing. I'll save a set of those. So then the next time I go to run a particular command, I just load those saved settings. Okay. It's pretty straightforward thinking, but be aware of it, because you're going to see many, many, many buttons in the software, but those are two that you're always going to want to sort of keep an eye out for, is the load and save. And if somebody in your organization, has, oh man, I can get my stuff to look like yours. What am I doing differently? Have them save out of the run the command to get to that dialog box, have them do a save, and then, you take it to your machine and load up those settings, that kind of stuff. Okay, now, in the settings and on the settings menu, there is this thing called a Carlson Settings Explorer. And that is sort of where the picture above here talks, shows you how a lot of settings are typically done, or they are done as a dialog box that comes up in response to choosing a particular command. The Settings Explorer, is sort of a global tree branch kind of organized thing that is the entire system. And at current count, there's close to 70,000, maybe slightly more, different settings in the whole software. But you can then sort of track down by command, and it will jump you to it, and you can see all of the settings are just put over here in this little spreadsheet format that you can edit and work your way through. So either way that you choose to interface with it, this can certainly help. And sometimes, you'll use it where if you don't really remember where you might have set a particular setting, you can go into this Explorer and you can use these filters and find and search buttons to try to find, where a particular setting might be. Okay, so it'll highlight and show you in the tree structure, as well as all of these are the expanded dialog box answers here as well. So it's not a normal way of interfacing with the settings, but it's there for you to use. Okay. So then once we get through talking about settings, and we'll do that here in just a few minutes. We're going to then start to really get into these basic concepts. And these are going to be the ways that we use the commands to create the things that we need in our model. We have to draw certain things. We have to draw line work. And most often we're going to be drawing polylines, which if you look there on page 11, there's a representation of a polyline. That is a 3-segment polyline. It's a single entity, but it goes from point A to B to C to D. It is composed of 3 line segments that could have been independent. So you can have independent line segments, and as long as the endpoints touch, there are commands that will allow you to join them up together into this single polyline entity. Now, I will tell you that polylines are so prevalent in what Carlson does, what Carlson's looking for, that I have over the years gotten into the habit that I don't know the last time that I actually drew a line. I almost always draw polylines, even if it is a single segment. That's generally what happens by drawing lines, is we just draw from point A to B, or from point C to D, or B to C, and just individual pieces. But I generally will draw those things and make it a polyline, even if it's just 2 points, just a single segment, because it then remains a polyline that other Carlson commands can then more readily interact with, because you'll run into a case where when you run a Carlson command, it says entity is not a polyline. You must select a polyline. And we have tools to turn things into polylines, but I've just gotten into the habit of drawing polylines only because they're so prevalent. They're so rife throughout what Carlson deals with. Okay. So we'll see some tools on how to draw those as well. And so we're going to see about this wonderful thing that Carlson has called points and point groups, and how Carlson uses points and point numbers. It used to be numbers only. Point numbers now means really point name. They can be numbers only. They can be numbers and letters. So we can use those as means of helping us to draw some things as well. We use them, and the reason, it's a natural outgrowth of what we're talking about here, and it talks about up here on these following pages, what these points are. But, here's a prime example, say over here on page 14. Maybe our surveyors have gone out in the field and they come back with a data collector full of data, and they dump in a bunch of points. And you see there's point 1 with an elevation of 101.35, point 2, 103.5, point 3. Now, obviously they have northing and eastings as well as elevations, because they're sitting there in relationship to each other. They're just not labeled, okay? They also you don't see a description on here, because when they were surveyed, they were just left blank. Okay, so they don't have to be, the descriptions don't have to be showing. However, if you were, and this is a bad example really of this specific set of points, but let's say you had to, for whatever reason, trace the outline. Maybe this was the outline of a parking lot. Now, granted, it'd be a kind of a crazy parking lot, and if you built that, you might want to, slink away on the weekend and hide because of those edges being so convoluted. But maybe, for whatever reason, that's the structure that we had to build. Surveyors go out there and they get us the corners, but all they do is give us points. How do we then draw And we either have to run the draw command, and then we have to say, you know, scroll down here or zoom in down here and go, you know, click on that point and then click on this point, click on that point, click over here and work our way around it. And then we get down into places like this and we have to, you know, oh gosh, we got to zoom way in and sort of click, find what we're doing. But we may know that the points were, say, surveyed by the surveyors in order. And so Carlson gives us this nice little tool using points that when you choose to draw a polyline using the standard CAD commands, it's going to say, pick a point. And you either have to pick it on the screen or you have to type it on the command line in the form of X, comma, Y, comma, Z. Hit enter. So it goes to that location. And then it says next point, or, you know, pick a point. In contrast, when you run a Carlson command, and this is the central thing, the central largest addition that the Carlson commands bring to us, is it says, you say draw a 2D polyline or a 3D polyline using a Carlson command. It's going to say pick a point or point number. And so now, instead of having to pick something on the screen, snap to something that's already drawn on the screen, if we want to go to its exact locations, what we call snapping, or to type in the coordinates, which will get old really fast, we can now, because we have those points, and those points can be on the screen, and get this, they don't even have to be. They just have to be in a file, and that file has to be currently active. So it reads them, reads their locations, and it goes to those locations as if we had typed them, and goes to point. If I type a 1, hit enter, it goes to point 1. If I type a 2 and hit enter, it then draws to point number 2. If I hit a 5 and hit enter, it would skip 3 and 4 and go straight to 5. But if I were to say 1-5, it would go from 1 to 2 to 3 to 4 to 5. Likewise, because if you remember this mangled mess down here, if I enter the question here, 1-22, well, guess what? It goes through them all in order, and I don't have to try to, you know, zoom down here and scrape away, you know, some of this mess to see where it's supposed to go. It knows by reading the file. So that is one of the greatest benefits of using points, is that we can refer to them by point number. And, you know, let's suppose we've got, you know, this, look at this figure, 1 to 2 to 3 to 4 to 5. So if you were to say going from 1 to 5, and then you realize later that no, it has to go up and down and up and back. So I needed to add a 2 and a 3 and a 4, and you just put those in order so they draw in order. But what happens if I need to do that same thing, say here between 5 and 6? Well, because of the Carlson point number with quotes around it, which really means point name, I can create 3 points and call them 5A, 5B, 5C, and then 6. And so then when I draw 1-22, it goes 1, 2, 3, 4, 5, 5A, 5B, 5C, 6, 7, 8, etc., etc. So there's a huge amount of flexibility using points, and we're going to, you know, get our feet wet on some of those and using point groups, which also help greatly. Do you, let me ask a question of your, I know because you're in different offices, But do you have surveyors in your particular office? Do you have them in-house that they'll go out and survey these locations?
Yeah, John just left. I mean, we are integrated. I don't know how much of that actually happens in terms of survey, but I mean, construction layout, yeah,
Yeah.
absolutely. But I don't
Yeah,
think John's
that's
team has any licensed surveyors per
no,
se.
no. I mean, in exactly what you're thinking about in construction layout. I'm not
Yeah,
so interested in whether you can resolve somebody's deed. That's
gotcha.
and we have tools for that in the Carlson software. That's I'm not not saying that, but what I mean is you'll go out and you'll get a drawing, say, from an engineer, and then you have to go out in the field and build that. So you need to know where those things are going to be. So this is, I think points are going to be very important. You're going to be able to set points on these things, then put them in a data collector and give them to the surveyors to go out and actually lay those points out. So, um, so we'll get a, pretty good immersion here in the points and using points and point groups. And then the next thing we're going to talk about after those points is the sort of the central theme or the bulk of what Carlson offers in terms of doing this type of work. And that is terrain modeling, the building of surfaces. And if you'll see, starting on page 18, there's a little introductory background page. And then it talks about the basic assumptions and processes involved. Gives you some examples of how to fine tune the data. Then what's involved with the modeling process and the data sources. So in the space of, let's see, we started with 18 and we go down through 23. So 5 pages, 6 if you want to count the actual error catching errors and how to evaluate. So 6 pages worth of what in traditional engineering education that might be an entire semester's training textbook. So we're going to go into that stuff in some real detail. Now, what happens here? What I want to make sure that you folks understand too is, we're going to get really in the weeds on this and really get a gut level sense of how this works, how the process works. A lot of some other instructors, I won't say a lot, but some other instructors will, they tend to say, well, these are for contractors and they're just using this for estimating purposes. So we're only going to teach them the takeoff way or the construction module way, the site net way. Whereas okay, if everything's on on these sets of layers, that's existing. Everything that's on these sets of layers, that's design. And then just hit the button, make existing, boom. Hit the button, make design, boom. And they go, congratulations, you're done. Well, yeah, okay, so you hit a button and you didn't get an error back, but you need to be able to evaluate this stuff. And knowing how that stuff gets built is going to be, key to that, because not only can you just, do those layer assignments for materials, but you can actually, even with the construction module or the takeoff menu commands, you can refer those things instead of just layer membership. It can also be done by building the terrain model first, setting it aside, and then letting the software refer to that as the design condition. So you'll see how we can sort of make a hybrid of this and get the best of both worlds. Because what we're going to be doing with all of our evaluation work, say like, figuring out how these triangles and surfaces and things get built, and how to manipulate those. So once, we're going to learn how to do that to really see if you can see these little lines that go up here. That's a curb line, and you can actually see it. You can see the island, the traffic island in here. But sometimes it might just look like, just a bunch of contour lines. And so if I'm building this, if I'm estimating it, I may not care about a little 6-inch curb. If I'm building it, I want to build my curbs. I don't want that to be slop. Okay. And that's nothing to remember from that little set of statements right there. You're going to see that vividly as we go through those controls and those commands. So understanding how we do that, how we use break lines, how we use points to create those surfaces, and is going to be key to helping us, create these things that we have to build out there on the ground. Okay. Last question before we jump into some of the settings for now is, would you say that the bulk of the information that you work with in terms of a drawing or a project, that you're trying to build, would you say the bulk of those come from drawings made by other people? I would say, that's probably a yes answer to that.
Yes.
And then next, are those mostly as PDFs, or are you finding more willingness from these designers to give you the actual DWG file?
Uh, I'll answer in New England area, it's 50-50.
Okay.
We do get some CAD files, more so when we're working on a design build project. Most of the public hard bids are still PDF.
Yeah. Okay. And so, and that
Rodney
makes
might
us,
say different.
yeah, that makes a certain amount of sense, because, the design build stuff is, you guys have to carry a lot of the design weight for that as well. Okay, so we'll need to go over some tools then as we're building these things up. We need to look at those, the tools that we have to quickly turn a flat drawing into a constructible model. So we'll see some of those as well. But I guess the first things we'll do is, I'm going to start us into this. We're going to start looking at the settings and just see some of the settings that we need to do. We're not going to dwell too terribly deeply here, but we will take a look at some examples of how these things affect what we're doing, and understand that we need to probably everybody match in the same office, to keep from having some confusion come about. So we'll pick that up. Now, normally I would get you started into that, and we'd spend, 15 minutes going through it. I was going to say we could actually break. We're 15 minutes early for the exact midpoint for our morning break. So what I'd like to do is just go ahead and declare our break for now. So we'll go ahead and take our break, and we'll come back at 10:30, and then pick this back up at that point. We'll try to get through the settings very quickly, and then after lunch we'll be able to dive into the really playing around with the points and the surface modeling and things like that. So any questions to this point? Anybody have anything you're working? I know we haven't really even opened the software yet, but does everybody sort of get a sense of where we're headed? Everybody okay with that? And if not, ask away or save it up, ask me at some point, that sort of thing. Okay. So I'll see everybody back at 10:30, and You'll see my screen come back. I'll go ahead and stop my screen share. So you'll see that come back up when we're ready to start back. I'll also verify that we're back. And I'm going to, okay, Rob, any of you guys that are familiar with this, can I simply start and stop the recording? So if I stop the recording and then I pick it back up after the break, it will deliver it to me as a single recording or even as a series of different ones.
Yeah, I think when you start and stop, it will create a separate file. So
Okay, but I'll get all of those individual files and I can then stitch those together.
you should.
Okay,
Yeah.
because
Yes, you should be able to.
okay, thank you. Because normally, what I'm used to with Zoom, there's a pause button, and so I don't see that here. But I assume this will stop. I'll start it up, and it'll come back, and I'll get that together. Okay, good. All right, so I'll see everybody back at 10:30.
Thanks, Ken.
Stop the transcript. All right, let's see here. Stop transcription. Yeah. There's no need to try to keep it transcripted. That's just more processing that gets in their way. So we are recording. All right. So we're going to jump in here and talk about settings, at least in as much detail as you're going to need to know how this affects your work and how to set it up correctly for making sure everybody's on the same page. So to do that accordingly, I want you to go ahead and start up your Carlson software. And I'm going to use Carlson with IntelliCAD here. And I'm just going to load up my Civil Suite. These are just loaders. I could have chosen this Carlson Takeoff. Either way, none of that matters. There's an update available, so we'll get that one another day. So once the software loads up, you can then freely switch between modules. So that's what we're going to do. Now, you may or may not see this start page. If you don't, none of that matters. What I want you to do is just go to a new drawing. And when that comes up, you're welcome to, at this point for the startup wizard, just go ahead and hit exit. And let it go ahead and come into your drawing environment. And you should then see a command line prompt down here on the bottom. And I like to be able to, when I do this, I pull this little command line window. This is just a palette that's floatable and you can dock it on the bottom. But I
I'm
want to
sorry. Sorry to
yeah,
interrupt. You hit new drawing and then what did you hit thereafter?
I just went next to the well, let me go back through that again, actually. I'll just come back to here. I hit new drawing and it comes up and says, all right, create a new drawing from scratch or create a drawing based on a template. And I just hit the next button here. And then it suggests a drawing template. Now we'll talk about those in a minute. And then I just hit finish. And then it comes up to this point and I hit exit at the bottom of that wizard. Okay, so that is an actual drawing wizard that I have on this configuration set up to go through. You may not get that little wizard prompt. It may just dump you into this like you see it here. And that's where I want you to be for right now. So we'll come back and talk about those other things on startup here as part of what we look at in our settings. So you should see at some point, you might see, these ribbons at the top, in which case that's fine. I tend to not use the ribbons simply because it gives me more screen space. You're certainly welcome to use them, and they're actually good and they're beneficial in the sense that they tend to group the commands based on workflow, whereas the pull down menus tend to be grouped according to functionality. As to, you'll have various things that might allow you to erase, but you might not have an erase panel on a ribbon, but you might see erase by layer on a panel that has to do with layers. So they're grouped a little bit differently. And none of that matters other than I'm not going to be teaching from the ribbons just because of, a lot of it's is going to be toolbar based. And we'll talk about which toolbars I have up here. You're certainly welcome to use them. I would encourage, particularly if you're used to using ribbon interfaces, maybe get comfortable with those and see if that gives you a little better way to navigate through the drawing. But once this comes up and you have your drawing area, you'll see up here at the top, I've got these two tabs. I've got that start page. I've now got this drawing 2. And if I had another drawing open, I would see its name over here, and I can freely switch between multiple drawings that are open at the same time. Now, when this does come up, yours might look like this. You'll see a lonely little command prompt down here at the bottom. And if you don't, I think, yeah, you start typing the word command line, and that's the command you want to run. And you would choose to show it. Okay, so right now by default, and you see you'll get default responses are in those little angle brackets. It says to hide the command bar. So if I were to hit enter right now, that command bar would go away. But it's an actual palette, and I could float it and put my command bar like this, and move it around. Any of those things are fine, but I'm going to dock mine. So I'm going to command line, and I want to choose lower. So I'm going to dock it in the lower part of my screen. Now yours might look like a single line. So what I would recommend is point the mouse down to that little dividing line. And when you see the cursor change shape, click and hold it and pull it up so that you're looking at least 2 lines above the word that says command. So that's part of the history, and you can scroll through it and actually go back up and rerun a command that's in there if you wish. But I want to see at least 2 lines above the actual command prompt, because a lot of times when it asks you to select objects, it tells you in the line or 2 above that prompt what it is that you need to be considering when you're selecting the object. Or if you do, let's say I just do a standard distance, I'm going to go from here to here. You see that? Now, in that case, I need to sort of up it a little more. So that gave me the actual starting point, the ending point, the distance, the angle in the plane, the angle from the XY plane, delta X, delta Y, delta Z. Okay, so that's an adjustable thing that you might want to raise that up and down. And it's scrollable. There's history there. You can go back to it. It's just like an editor. Okay. So make sure you can see at least 3 lines in that. All right. So now, part of the interface, for those of you new to CAD in general, is the big blank area in the middle. That's where we're going to be building our drawing itself. And you're going to have commands like, if you'll go to the draw menu, for instance, and choose draw a 2D polyline. And if you do not see this dialog box, then that means, hold on a second here, let me get that now. So if you run the command and you don't see anything here, but look down on the command line, you see there's continue, extend, follow, options, pick point, or point numbers. There's that point numbers thing again. Go ahead and choose the options, and that will pop this up. And so you can turn this on that you want to. Anytime you run the command, you want to see the options box, because that lets you set an elevation or set an elevation by the first point you snap to. You know, some offset. You can automatically square off your corners if you're just drawing something that looks like a square within a certain tolerance, and you can't really set the tolerance. But then you can use the current drawing properties or not. And if you don't, then you are going to choose a layer to put these things on. You can set a color and a line type and even a code, which is a field to finish code. We won't worry about those for now, but that lets you sort of control what gets drawn and how, what it looks like, and what layer it goes on based on a code definition. So right now we're just going to be controlling these. And so let's click on use current drawing properties and say, okay. Now nothing happens here, but on the command line, it says pick a point or point numbers. So just click a point, move the cursor. You click with the left, let it up, move the cursor, click another point, move to here, maybe up to here. And now one of the options is to close. See down here on my command line, or you could just type the capital letter C that you see down there. So C to close and hit enter. So that now has a closed polyline, and closed means that it is mathematically closed. So I have this figure, I select it. I'm looking at my properties in this right-hand panel. Now, if you don't see those properties, right-click the mouse and choose properties, and you'll get that, and it might show up as a little floating palette like this. In which case, so what I did was drag this over to the left-hand edge and until it docks. And so now that has a set of properties. The properties that you see on that object are what color it is. And right now you can choose a color, or it can be a color, a special color called by layer, meaning that it's going to take the color that is defined for the layer that it's on. So right now it's on layer 0 because that was my current layer when I ran the command. If I switch that to be layer final, see how it changes to be red. If I put this on layer existing, it's yellow and it's dashed, it's broken, has a pattern to the line. Even though this line's not broken, it actually goes out to these corners. It's just that the pattern of the line that goes through it has gaps in it. Okay. So those are what are called the properties of these entities. And they're going to show up if they exist in the drawing. They'll be in this graphics area. Okay, so that's part of our interface here. Now, you see me zooming in and out, and I'm doing that by rolling the wheel on the mouse. And if I want to keep it at that same zoom level, but scoot it over a little bit, now I'm not going to physically take it and move it, which you can do. So that's now changed the position of that object. I could just change the position from which I'm viewing it. And you do that with what's called a pan command. And the shortcut for that is just like the wheel zooms in and out. If you press and hold the wheel like a mouse button and keep it down, notice the cursor changes to a pan cursor, and then you move it around to where you want the drawing to be and you let it up. Okay. A couple of other options. Let's say if I draw another object down here and maybe a circle up here. And then if I'm zoomed in here, but I've got other things off here, there's a command called zoom extents, and you can get there just by typing Z and hitting enter. That's zoom. And I've got all of these different options, a lot of which the wheel mouse does for you, but one of those is extents. So when I choose extents, it draws to fit everything in the drawing screen. Now notice I really only drew these three objects, right? But if I do a zoom extents, Z, enter, E, enter, it goes up here. Now this is sort of, I don't necessarily call it a bug. It really is a bug, but it's not a broken bit of programming. It's, as the salesmen say, it's a feature, not a bug. What it's doing is it's telling me that, all right, this is where everything that you have in the drawing is on the screen. Well, that means that it had to make the screen big enough to include everything. So up here's really the only things I've drawn, but that means that there must be something way down here. And there is, and it's right at that point 0, 0. And I'm going to draw a little window around it to select around that 0, 0 location, which is where this cursor is located. And so I clicked, I'm dragging down and to the right. I'm going to click again. And it says no selection. Well, let's see. There's something somewhere. Where is it? Huh. I don't see it. Hold on. If I select all, it gives me 4 things. Oh, okay. It was over here. It wasn't exactly at 0, 0. It was, well, it is at 0, 0. I had zoomed out beyond 0, 0. So if I look at this one particular entity, first of all, I've got 4 things selected. 2 polylines, 1 circle, and this 4th item. And I look in my properties, everything that's selected now shows up in my properties, and I see these 4 things. I've got 1 circle, 1 point, 2 polylines. And if I wanted to go to, say, those 2 polylines, I can then change their layer. Now it says varies because one is on one layer, one's on the other. I can then switch that to, let's put them both on final. So now they're both together. But if I look at this point, I look at some of the properties of that point, I see that it is at position 0, 0 with an elevation of 0. Now this is what I meant by that being a little bit of a bug. There are certain commands, and it probably happened when I interrupted my draw polyline command to show you the options, is that part of that command actually throws a point down there at 0, 0 to start its work. And then it normally, when it concludes successfully, it erases that point. But sometimes you'll get those points left over in the case like we just see here. All right, so I'm going to press escape, and that's going to clear my selection. And I'm going to sort of remember where that area was down here. I'm going to just draw a big box that should grab it. And I'll hit that box. And so there it is. Now, I don't need that point. I recognize that it's there, but I didn't need it. so I can erase that. Now you can just press delete on the keyboard, or you could find the delete command on the toolbar, or you could go to edit, erase, single, and because it was selected, it erased what was selected. Okay, so now if I do that zoom extents, it expands the drawing screen such that everything is now visible. Now, none of those things are changing size. It's just the size at which you're viewing those objects. Now, just like this, rolling the wheel is the same as typing Z for zoom and then in or out, and pan is another command. I can do that with the wheel. I can zoom in and out. I can press and hold and move it around. This is just moving my viewpoint now. I'm not moving the objects.
Is it at all possible to change the background color? I can't really see anything on your screen other than that one circle.
Oh, really? Okay, certainly. Well, first of all, I can do this. That might be helpful. So they're now there, but if I change that screen, let me see if this might help. My colors, I'm not sure where to do this necessarily in.
If it's in IntelliCAD, it's under settings IntelliCAD display.
Yeah, it should have been. Well, it's either IntelliCAD options. See, there's also IntelliCAD settings. So
It's IntelliCAD options
it is in options here, and it's under
display.
display. There we go. That's what I'm looking for, is this color scheme. I've got a dark theme that's for the icons and such. I guess my color scheme. There we go. So this is what's called model space as opposed to paper space. So if I use my model space and if I set the screen background, let's see. I just change it to white. I don't know that that necessarily would see, that makes my circles different. How does that show up on your end? Is that better?
I mean, I can definitely see it more clear now, but when you made the lines thicker, that was sufficient as well.
Okay. Problem with white is that these grays and such, see that this one is also, that's a color by layer, which is color 0, which is, it switches to black. If you're on a white screen, it switches to white on a black screen. So let me see if I can find a little better compromise here. No, that's worse.
I mean, I think if you made the lines bolder, like you did, it would probably work in black just fine. I just couldn't see before.
All right. Okay. So yeah, we'll do that. Now, I can also notice what I'm doing down here is I'm double clicking this icon at the status bar. That's to show the line weight or not. So I'll make sure that you can see these things. Make that a little bigger so you can see a little better. All right. Yeah. So great. So anytime you get something like that, if it's a problem, let me know and I can change it so it shows up better. Now, so that's a couple of ways to navigate. Now, one of the things, instead of typing Z, enter, E for extents, enter, which works certainly, there's a shortcut for that as well using the wheel, and you just double click the wheel just like it's a mouse button. So if you double click it, it does a zoom extents. Okay. And there's another one is if you choose this, if you have this icon showing up here, which is the drawing navigator, if you just click that little top button, it puts you in plan view and it does a zoom extents. So, you might be at I'm at a perspective view. And if I click top, it's going to go back to there and do a zoom extent. So all of those were going to be ways to get to that point. Okay. So that's a lot of what we do with these drawings is that we have objects drawn and we select them, look at their properties and change them if we need to, or run a command on them. So if it's selected, if I wanted to copy that, for instance, and there's a number of ways to do that, I can right click the mouse and there's a number of editing commands that apply to whatever I've selected, one of which is copy. So if I say copy, now read the prompts. It says specify a base point or displacement or whatever. I can just click. I'm going to copy from there to there, and I can keep making multiple copies. When I'm done, I just hit enter. Okay, so I can also select it and choose, say on my modified toolbar, there's a command here that says copy. It's the very same command. Now, if I select it and choose edit, copy, standard copy, it again does the very same thing. But if you choose it and choose edit, copy to layer, notice what happens is it deselects it and it says select entities. It says filter question mark select entities. And then in the line above it, it says select the entities to copy. So that might be, say, this and this. And I'm just picking on these things individually, or I'm doing a window, a crossing window, or an closing window. Once I'm finished selecting, it tells me I've got 3 things in my selection set. Once I'm finished selecting, I hit enter. And now it wants me to choose a layer to put those on. Well, I'm going to put those on my layer existing, for instance, and say, okay. And so now you see there that got one that's right over top of that. So that's that one. I've got one right over top of the other because it copied them right there where they were, but copied it to that layer. So see here, I've got 2 entities, and when I hover the mouse, I'm not clicking, you see a little icon. And it shows, it looks like 2 little stacked rectangles. That means there's multiple items there. And if I click on it, I get this little dialog box or this little pick box. I can select everything or this polyline that's on existing. That was the copy. There's the original, or I could say none. Now, you may or may not see that little icon, and it has to do with whether or not you have selection cycling turned on. And you turn that on by down here on the status bar. You're going to want to go to the there's I think if you just, let's see, you can right click. You go to the far right and right click, and these are the things that are down here on my status line. Notice I've got this, you should see cursor coordinate values, and that's this little set of numbers down here. And that means as I move the cursor around, you're going to see these numbers change and tell you where you are in the drawing. I've got the one thing that I've got down here is selection cycling, which is of course I can't find it. It's cursor. No. In AutoCAD, that's available down there on the status bar. In IntelliCAD, let's see, if we type selection and then we choose cycling, right now it's set to 2. If I look at that and choose the question mark, here's what they can be. If it's 0, the visual aids are disabled. That's that little icon that tells you there's more than one item under your cursor. If it's set to 1, it displays the icon when you hover over it. If it's set to 2, which mine is, it shows you both the icon and the selection cycling list, that was that little pop-up box, are enabled. And if it's set to 3, you don't get the icon, but you'll get the list. Okay. And then it tells you if it's set to a negative value, the visual aids are turned off, the original setting is stored, Control W to toggle it on and off, etc., etc. So by default, it should probably be set to 2 so that you can see that little icon and then know that if you pick, it's going to pop this list up and let you choose one of those out of the group of things that are overlapping. Now, like I said, in standard AutoCAD, that's governed by one of these down here that you can turn it on and off with the bar. Apparently in IntelliCAD, you have to do it with that command called selection cycling. Okay, so if you did not see that, you would bring that up. Now, when you hover over something with the mouse, in AutoCAD, that will sort of pre-highlight as if telling you that you're getting ready to select that object. It's called pre-selection. And so in the case of doubles, if you do that, you can then hold the shift key and hit the space bar and all that kind of stuff, and it will cycle between all of those different ones. But IntelliCAD's selection cycling works with this. AutoCADs can do that as well, but that lets you pick something that's there. So I'm going to take that original one that we copied and delete it. So anyway, the point of what I was making there before is this. Some commands you can pre-select the objects that you want to do the command on. I've pre-selected those now by just clicking on them. You see the grips, and a lot of times the grips, you can just grab a grip and move it and it will, change its position. You can, in case of polylines, if you hover over these 2D polylines in the middle grips, you can convert that, say, to an arc. Or hover over it and convert it back to a line, that sort of thing. But because these two things are selected, a number of things happen. You see them show up in the properties, and I can choose individually. Let's look at just the circle. And now the properties for the circle are here, and I can change its layer. Let's put that one on final. And let's change its line weight to, instead of whatever the layer says, let's make it specifically 0.5. So now you can see it. And again, you can right click the mouse and do these standard CAD commands like copy, move. So move instead of copying. If I click, I'm going to move it from there to down here. So it's now moved those items. But those are when we pre-select things, that's called, that's the what, that's the noun. If we then run a command on it like move, and I'm going to just right click and choose repeat move, that's the verb. Okay, so this is called noun verb selection. We can also run the commands. I'm going to right click and choose move. And now because nothing was selected, it prompts me down below on my command line to select the entities I want to move. So I'll pick those same 3 things that I had before. Hit enter to finish my selection, and then I'll just move them to a new location. Okay, that's called verb noun selection. So all of the AutoCAD commands or the IntelliCAD commands are going to work in that regard. Most of the Carlson commands will not. If I pre-select, so I'm looking to do noun verb selection, and then I go to, let's say, edit. Let's see, what might I want to do? Those are just standard commands. Well, let's do that copy to a layer. Notice it clears the selection and then asks me to select the entities. Well, I just had them selected. So that's another thing you can do is type the letter P, meaning previous things selected, and hit enter. So that let me choose those. And I can add to this now. I just keep going and select objects, hit enter, and then that brings up the rest of the command. Now, the reason for that is the reason Carlson doesn't do a lot of that, doesn't let you pre-select them, is because you sometimes have to answer questions in a dialog box about where these things go, and that may limit the type of objects that you can do that particular command on. Like some commands might work on circles and polylines. Some commands might only work on polylines, but not circles. So it clears the deck and then prompts you to select what it is you're trying to do. Okay, so just keep that in mind that sometimes you can pre-select, sometimes you can't. Usually on a Carlson specific command, you cannot. Okay. Now, a couple of things about selecting. You can select objects by simply clicking on them. So I'll click once on that one. Let's click right in here. You see where it doesn't know which one I want, so I'll get that icon. So I can click here. Now, if you hover the mouse, I'm not clicking yet, it tells you which one you're getting ready to select. So I'll select that bottom one. And now maybe I'll select this guy. So that's one way to select. And notice, like right now, all I'm doing is building a selection set, and I can keep going to it. Now, there's several things that you can do to continue to select items. You can keep picking, or you can draw a window around certain things or through certain things. It's what we call an enclosing window or a crossing window, and it works in a shortcut way. Or you could type it by typing WC for crossing, or forget what the defaults are, because the commands all work by shortcuts. So if you click once and you drag toward the right, either up or down to the right, notice it's a solid blue. And if I come down here and select this solid blue selection means that everything that I want to select has to be completely within this window. So now I'm only going to select those 2 items. I'll press escape and I'm going to do it again, but this time instead of doing this, I'm going to click and I'm going to go toward the left. And so now you notice the window is green and the edges are perforated. Think of that as like saw teeth. So what that means is anything that saw touches is going to get cut. It's going to get selected. So all it has to be is either completely inside or partially inside. So if I draw to the left and click, it gets everything that touches the edges or are also within. Now, those are selected, and I can keep selecting by any other means. I can just pick. I can do a crossing where both are selected. I can do a to the right where only the things that are within it are selected. Okay, so those are ways to select objects. Now, here's the full list of selecting. And again, most of them you're going to just do without thinking using the mouse. But if we look for select, see if I can find selecting entities. Now let's turn that off. So you can select by a number of different ways. You can select by these filters and select by certain values. We'll see those when we start to work on some of these things. But here was this selection preview I wanted to look at earlier. Zero, 1, 2. Okay, so default is 3. This is a selection very high to be selected if you click the mouse. All right, so if I turn that on as 1, so that's selection preview. Sorry, I wanted to set to, right now it's set to 0. So that's what I wanted to show you. This is an object. If I hover the mouse, see how they sort of pre-highlight? That tells you what you would select if you were to click the mouse. It sort of gives it a little dashed look. And it's just a variable that gets set. And so now it's not when I'm doing this, but if I were to type a command, copy, now if I pick it, you see it's going to tell me what I'm going to select in that regard. All right, so I personally like to have it set to 1, but again, it doesn't have to be there at all. You can just leave that as it happens to be. So back to where we can select things. If I can get this to stay open. Let me look under index. Here we go. So you can create a selection set that consists of one or more of these things for modification. You can either choose the command or tool first and then select. That is your verb noun. Or you can select the entities first and then choose a command. That's your noun verb. And you can select by clicking and then use the grips, of course. So here are choosing a selection window. There's left to right, right to left. We talked about that. And then here is a list of all of these different little subcommands when you're selecting entities. When you're prompted to select entities, if you type the word all, that selects all entities in the current drawing, and that means all entities that are visible and they are on layers that are thawed. If the layer's frozen, you can't see it, and the CAD system doesn't know anything about it until you thaw the layer. You can add to the set as you go along by typing the letter A to add, or the symbol plus. You can remove from the selection set by typing R or minus. Here's that P letter that I used before when it said choose the previous selection set. So even though I had them selected, I ran the command and it cleared the selection. I just type P to hit enter and it goes back and reselects them. L means get the last thing or the most recently added thing in the drawing. W, that's the window. That's the left to right, meaning it has to be on the inside. Crossing is the right to left. That means all it has to do is cross the edges. You can also select by things that are outside of a window by typing O. You can choose a non-rectangular window by choosing window polyline or polygon, crossing polygon, outside polygon, and you can also do them with circles: window circle, crossing circle, outside circle, or you can select any closed entities that surround a selected point by a PO. You can select by fence, which lets you draw a line that crosses. And then there's a quick select and then a select by properties. So just as an example here, this PO. So if I want to select all of the entities that surround a point, so I'm just going to type the word select. So select entities. If I type PO and hit enter, it now says pick an interior point to select any closed boundaries. So if I click right here, it now highlights those up. Those are selected. And I'll hit enter to finish my selection set, and you see where it got those. Same thing, if this one overlapped, I'm going to just move that into here. If I then chose select and type PO, and if I hit here, let me see, PO, if I click here, it's only going to select that one. If I select, type PO, and if I click down here, of course, it's only going to select that one. Then, like we saw before, if I select in this common area here, it selects them both because they both are closed and they both surround the point I picked. Now, that's one selection technique that may or may not be useful for you. I will tell you right now, I never use it simply because it's not in my daily workflow. I do almost everything I need to do by these crossings or inclusions or pick. Okay. And if you pick something and you, let's say I picked here and I got all of these, oops, but I didn't mean to get this one, then I would type R to remove. And now, whoops, sorry. Let's say copy. Let's give a command. I'm going to pick some points here. And let's say I did these and I say, oh, well, I didn't mean to get this one. So I'm going to type R to go into remove mode. And so I'll pick that one. You see it unhighlights. And I'll pick this one. So now that's removed. I can type A to go back to add mode. and then pick a couple of these extras. And so now just the ones that are in that set that I built. So you can build these selection sets a number of ways. You can also select a given item and right-click the mouse and choose Select Similar. So it found another circle that shared the properties of being on the same layer, the same line type, and those are the only ones it selected. If I select one of these and say Select Similar, it gets all the white circles. If I happen to select two of different types and then select Similar, it gets everything of those two different types. Okay. Finally, you can build a selection set with this quick select, and it lets you choose all of these different things that might be in the drawing based on different properties. Let's say on the layer that equals or is not equal to, or select all the layers, etc. And you can include them in a new set. You can exclude them from the set you're building. You can add them to the set you're building. And once you've done that, you may then choose those objects. Let's see, I did this, and then if you choose that particular one, it identifies it, its color, etc. That's that little pick button in the top up here. So there's all kinds of tools all over the place that allow you to do certain things that you're trying to do. My suggestion to you, until you've learned those and sort of made them second nature, is to try them out, see what happens, because there's always this lovely little edit undo that you can put things back to the way they were. Okay. Now, let's talk about some settings. And this is going to be sort of brutal. I apologize. So if you've got coffee, hang on to it and use it. But these are some things that are sort of important to know about. So let's go to the settings menu and choose Carlson Configure. It's the third guy down. And that brings this up. And this is the top level settings that control everything in the drawing. And you notice if I do a save as, and I'm going to put this one, I'll just call it before class global settings, and I hit save. And yes, I'll overwrite that. Now, when it comes up, oh, I said there are over 70,000. Looks like there are now 96,422 settings that's saved. Okay, now you can't get to all 96,000 through these buttons. Sometimes there are settings that are buried within a dialog box, within a dialog box, within a dialog box, within a command. But this is where we're going to control the bulk of how the system operates. So one of the first things that we want to look at for what your prime work mode is going to be is down here in the lower left. There's this button called Takeoff/SiteNet Settings. Remember, I told you Civil has that SiteNet menu, and so this applies somewhat to that behavior. But we're going to, since you all have Takeoff available, or the construction module, we're going to look about what these do, and I'll explain a few things here, and they'll come into play later as we go into those commands. So in this upper box, and if you can see on your screen, you probably can't on mine necessarily, it says surface modeling, and there's a little faint frame that outlines that. So this has to do with surface modeling. Over here, the frame has to do with takeoff entities color assignments, and then down below, the surface file suffixes. Okay. So first on the surface modeling, when you're doing takeoff modeling, the basic workflow is this. You select or create a boundary perimeter. That's going to be the end of your world in that model building. Now, if you say you want to extrapolate a surface, whether that's existing or design, out to that boundary perimeter, that means, let's say you've got a couple of things that have defined the outside edges of what you're building. Let's say it's the back edge of a parking lot, for instance. And then you say, I want to extrapolate that out to the boundary. Well, it's going to take whatever those elevations are along the back edge of that parking lot, and it's going to basically push out till it finds that boundary and just push that surface definition all the way out there. If you do not have it checked, it's going to end at the end of your data, which is generally what we want. I'm not sure even what the default condition is out of the box. It may be checked, but what we need to let the system do for us is we want to go out to the edges, and then if we need to tie that edge into something, we'll typically run a command that is going to tie that at it, say, a given slope back to the existing surface, if it's a design surface that we're talking about. All right, and so if you did, though, turn that on, that's going to push your design out, and it says use the existing surface to extrapolate the design surface, meaning it's going to go up to the edges of your design, and then it's going to drop down or raise up to find, and that's vertically or near vertically, until it finds the existing surface, and then it uses that to push all the way out to the boundary. So I'm going to generally uncheck that, and we'll learn how to tie those down the way we want them to. We do generally always want to use a binary triangulation file format. There's no particular reason not to. You can use, it's what's called an ASCII format, and it just writes it in the form of a text file. And you want to minimize flat triangles for the existing surface. Now that has to do with when you are computing existing features. If you are creating those from drawn contours, that happens to be, if you don't do that, when you create those existing features from those contours, think about the contours that go up a flow line of a gutter. So they're, these nose-shaped contours. When all you're looking at are the contours, it's going to tend to look across and find itself as it doubles back, as it's climbing up the face of the curb, and it's going to flatten those areas out. And so all of your flow lines are going to look like stair steps instead of nice, smooth flow lines. And again, we'll see that a little more detailed understanding of it. Same thing as if you are building your design surface, say from a bunch of drawn contours, you're going to want to minimize your flat triangles for your design. Now, there's times when you don't want to do that because sometimes you've got other data besides contours that are going to help you model the existing or the design surface. And so when that's the case, you want to turn those off. But if you're really coming from the contours, you want to come in here, look at this again, and turn those on when and where appropriate. You can densify your break lines, and we'll talk about that when we get to the terrain modeling portion of it. I generally put that on and go every 10 feet. So if I've got a long feature where I've only got the 2 endpoints done, if I don't have additional points in between there, the triangles that form against that edge are going to be one big gigantic triangle with a base the entire length of that feature. if I break it up into these segments, I'll get multiple triangles through there so that I get a smoother surface. Okay, so if you choose to draw the triangulation surfaces, you can choose to draw it as 3D faces or as a surface object. Now, this is not fully developed yet, so I would leave it as 3D faces. Carlson is in the process of trying to bring these surface objects internal to the drawing and create what are called these extended entities. But it also still always saves everything about the surface definition in external files. So it doesn't really matter here, except you won't see these surface objects actually get created. So I'm going to put mine back to 3D faces here. And then if you have a large, let's say a 6,000, 10,000 acre site, you might want to reduce those surfaces so that they don't take so much processing time. And you can set it non-existing design or both, depending on what you're doing. Had a client out in the East Coast area of, or not the East Coast, but in the Tidewater area of Virginia, outside of Richmond. There was a big nuclear power plant out there, and they couldn't get the surfaces loaded on their equipment to be able to go out and grade the site because they had literally millions and millions of these triangles in that surface, and it just overwhelmed the memory capacity of that equipment. So to resolve that, we had to go through and reduce those surfaces, and it basically looks at neighboring triangles and says, hey, if you're within a certain tolerance, I don't need 5 triangles here. I can get by with 2. And so it goes through and looks at all that and thins it out and still keeps the surface definition fairly accurate. So, you know, it depends on what you're working on. If you're doing huge sites like that, you might want to say that, yeah, I'm going to reduce this stuff so it's not so heavy. Or you can always do this after the fact. So this is the way I like to see them, as none. Now, coming on down, we talk about these surface file suffixes when we're talking about takeoff and sitenet. We have 2 conditions. We have existing and we have design. Well, and then an over excavation surface, but that's a target surface. So basically, we're going to be defining our boundary, defining the elements to make up existing, defining the elements to make up design. Then we're going to build those 2 surfaces. And we have 3 different versions of each of those surfaces. There's one that is before any adjustments on the existing ground. And then if you have identified subgrade zones in your existing ground, and if you've identified topsoil stripping zones. So basically, here's your raw just top of the ground surface, and it's going to be called, the existing and design surfaces are actually named the same name as your drawing file name, and then it sticks these little suffixes on the end of them. So if this drawing right now is called drawing2.dwg, if I built an existing surface, it would be called drawing2-og.tin, drawing2-ze.tin, and -ex.tin. So here's the unadjusted. This is after all, or this is after all of those adjustments, after your topsoil stripping, etc. Same thing on design. No adjustment. Any subgrade strips, like if you've got a parking area that has, 2 inches of asphalt, 8 inches of stone, and 12 inches of subgrade, and then what you're left with that, and then if you put topsoil replacement back on top of those, that final surface, and that's the FN. That's what stands for final. And you could, you can make that anything you want. You could spell out the word final here. It's just this gets added onto the file name for those surfaces. Okay, and so I generally left mine by default, and I've just learned what they mean as when I go to look at those surfaces. Now, finally, over here in the upper right, these takeoff entity color assignments. And these are if we automatically update the colors and we assign the colors based on the target. So when we do that, it lets us choose what color do you want your existing entities to be? What color do you want your design entities to be? And then what color do you want everything else, other, to be? And when you do that, as we start to build these existing and design conditions, you're going to see the drawing, even though it has multiple colors and it's usually based on layer definitions, they're going to change color to be green for existing, blue for design, or whatever color you choose, and then sort of a gray for other. And then also, if we assign colors by elevation, we can say if it doesn't have elevation, make it red. Now, again, you'll see all this play out when we go to elevate a PDF file. So when this happens, we can see in the drawing quite readily whether something has gotten its assigned elevation yet or not. If it's still down at 0, it's going to stay red, even though it should be either green or blue or gray if it's other. It usually, we want to see it change color to match this up here only if it's elevated, if we have this checkbox on. So if it doesn't have elevation, it's going to be red. And so again, that's just a visual way for us to, without having to look at everything in the 3D view, we can see it still in plan view and know that it's been elevated or not. Now, this part of this, the green and the blue part works, but this assign color by elevation does not work in SiteNet, in the civil part. That requires the takeoff or the construction module for that to show up. So that's actually, I've seen some customers will actually buy that module just to get that functionality, because if you're trying to elevate, a couple of thousand contour lines from a PDF file where they're all flat 0, you don't want to have to do a few and then you forget whether you did one or not, and you have to look at it in 3D and say, okay, that one's not done, and go back and fix it. So this is a really, really useful tool for us here, okay? So set those accordingly and choose okay. I'll leave this up here for a few more seconds so you can match if you like. All right, go ahead and say okay. And we'll come back to our main screen here. Now we can skip all the mining and section hydrology and such. Go ahead and take a look at the survey settings. And there's just one thing I want you to check here is the CG survey menu. If it says compact, go ahead and choose none. There's no need to have that menu on our menu bar. We don't really need it. And that should be all you need to worry about on that one. And then on your surface settings button, the one I want you to choose is to have these 3 checkboxes at the bottom. Make sure they are on. Okay, because that allows you to work on surface edits, and it tracks that history so you can apply them again later. Okay. Now, these top 4 buttons are going to be what affects our drawing and our CAD, behavior as we're working on it. So the first thing to look at is this project data folders. So go ahead and click that, and by default, it should come up and say drawing folder. Now what that means is basically follow the drawing. So wherever the drawing lives on your computer, on a network, or wherever, all of the files that we create, whether they're center lines, profiles, surfaces, whatever, they're going to go in the same folder as that drawing file. Okay, and that is the default behavior, and that's the easiest to manage. The other two options are you could specify a certain fixed folder and just go, you might have a big giant folder somewhere that says data files. Everything's going to go there. And when I say everything's going to go there, I mean, when you create these things and it asks you to save the file, that's where it's going to start looking. You can always change that location on the fly in the middle of those commands by navigating to a different location. These are just setting defaults. The other option is to use a project folder setup. And if we choose that, we look at our project subfolder setup, and you may not have anything here, but this is just as an example, a list of different folders that I have pre-created within my project definition. I've got, first of all, whatever the project is, wherever it is, whatever it's called, that's just a placeholder. Within that, I've got a folder called data. I've got a folder called DWG files. I've got a folder called other, and I've got a folder called program settings. If I open up data, I see I've got a folder called alignments and profiles, deed information, mining stuff, and points. And points even has two subfolders inside of it. I've got deed points and field points as two different locations. Okay, now this is just a sample. And then I've got a folder called surfaces. You see it's at this same level as points and data. So that's where my surfaces will probably go. Now I'm out here in my drawing files, and I've got other, and I've got like contact or contract information, deliverables, point clouds, PDFs. So this can be anything. They don't have to even be Carlson related. They can be just any kind of a structure in program settings. Okay. So once I've defined that, I can then choose my data type subfolders, and I get this. I see all of the different folder or all of the different file types. Like here's a CAL file, which means it's a mining equipment calendar. Well, I haven't assigned it to anything specific. I could come down here and choose mining stuff, for instance. Here I've got a .call file, which means it's a draw leader with text. Wow, I have no idea what that might be. And so you might put that in settings. You don't have to put these anywhere, but whatever you choose to design, you have here, or whatever you choose to assign is where these things are going to start out looking for the location. So centerline file, I'm going to put it in project data alignments and profiles. But my culvert settings, I haven't assigned anywhere yet. So those are just pre-built default locations as to where I want to put some of these files. Now, we're going to be working with drawing folder only, and we'll just take the defaults for all of these, for the rest of these. But here's a little trick that I wanted to point out here. Let's say and you can leave yours up here, but I'm going to go out here. Let's say I encounter a file. I see a file out there called a .grd file. Well, what is a GRD file? It's a grid file? Is it a grading file? I don't know what it is. If you go to that command, settings, Carlson configure, and you choose project data folders, temporarily switch it over to project folders and then choose this data type subfolders. And now look at this list. It's in alphabetical order and you can sort them by clicking on these different headings and reverse the sort. Now I'm going to look for that GRD file and I see GRD, right there's my GRD file. And I say, oh, that's a grid surface model. So that's sort of like a TIN file, which is a triangulated irregular network, but this has to do with gridded surfaces as opposed to triangulated surfaces. And so that tells me what that file type is. And I can see I've got, in this case, 271. You may see a different number depending on what version of the software you've got. But that's a nice way to help you identify what those are. And then you just cancel your way out of it, set it back to the way it was, but cancel back and leave it sitting at drawing folder. So just a little trick to help you identify some files. Now, let's look over to the right there at startup settings. And this is what happens when you start Carlson. Right now, remember when we came into the drawing and we said new drawing and it asked us to from a template, and I just hit next, because it was sitting on this particular template file, is my Carlson DWT. Now I can put that, I can choose any one of these. There's AutoCAD named plot styles, AutoCAD ISO, there's map book, there's civil demo, there's Carlson, National CAD Standards, civil, there's any of these different startup template files that I can use, and they come from this template folder that you can see it's buried pretty deep in your settings. Okay, and that location is configurable, but it comes out of, by default, it's in the users folder under your login name, under app data, roaming. In this case, it's pointing to Autodesk. I'm using AutoCAD templates, even though I'm running IntelliCAD. So, you might have it set to a different location. So there's Autodesk. If I go to Carlson, then I could come down here and find my Carlson 25. I think this one under user, nope, under support. Now it should see down here are some templates. There's Carlson National CAD Standards for Survey, all of these different countries, Carlson 21, 24. So those are all different locations that I can preset a template that I want to use to start with. Now, those of you new to the CAD system, the only thing in the world a drawing template is a drawing file, and it has its extension changed from DWG to DWT. Okay, so what that has the effect of doing is it opens that file as if it were a drawing file, and then does a save as to your file name that you want to use. That's how templates work. And we use templates to hold all kinds of settings, layer definitions, the names of the layers, the colors, the line weights, the line styles, defined text styles, saved system variables like we talked about earlier, that selection cycling, or that selection preview, those ones that we looked at earlier where I changed a couple of numbers and changed their behavior. If you preset a particular file to get everything exactly the way you like it, then when you save that, you can save it as a template or just find the file out on the system, copy it into the template folder location and change its extension from DWG to DWT. So that's all in the world it is. It's a starting point. Now, I would suggest if you don't have one that you use for your work, if you've got a project that you've done in the past that everything is set up the way you like it, you've got the layers built, you've got the colors and the line styles and text styles and everything set the way you like it, take that file, copy it, change its extension to DWT and put it in that template folder location. Okay. And then when you start up a new drawing, you'll be able to select that as a starting point. Now, again, it's a drawing. It can have things pre-drawn in it. It usually does not. It can also have multiple layouts down here on the bottom of the screen. You see where I'm looking at model. Then I've got layout 1. These can all be different paper configurations as if you're going to plot a set of drawings. You might have one called 11x17 TB, meaning 11 by 17 title block. You might have another one that says ANSI D TB. So it's a 22 by 34. That's the ANSI D specification title block. And within those, they could have drawn sheet borders and titles and placeholders and everything that's going to help you get things ready for your work. Okay. I wouldn't spend a whole lot of time chasing the tail on that particular dog, but like I said, if you've got a project that you've done before and everything's like you like it, you might consider using that as a starting point by making it a drawing template. Okay. And then right now, this Carlson 20, 24, 25, whatever you're using, project folder default. This is by default the top level of where you're going to start looking for Carlson drawings and things like that. When you choose open, it's going to start you in that folder location. Again, you can browse to a different spot, network files, anything. Profile name, I would leave it set to the way the installation set it. And then this /no logo switch just suppresses the IntelliCAD logo when it loads up. You can also skip the splash screen if you don't want to see the pretty little Carlson picture as it starts. So that's just what happens when you launch the program. Okay, so we'll say okay. And it says, okay, you've updated those successfully. Now we got 2 more buttons to get to. And one is the drawing setup. Now, this is what happens when you create a new drawing, which is also typically done at starting of the program, but it could also be done in the middle of when you're working. You might just choose to make a new drawing. So this is what happens, and these are defaults that we preset, again, to make this behave. We're going to choose English units, 1 inch equals so many feet. And of those units, we need to choose either US survey feet, that's what US feet means, or international feet. Now, this is changing in the world, in the industry. Supposed to be this year, the American Congress on Surveying and Mapping is switching from officially using the US survey foot definition to the international foot definition. Now, the difference between these two definitions is very, very slight on a small single site basis. But if you're doing long corridor type work like pipelines or roadway designs, if you're over about a mile or so, you're going to start to notice a difference in those units. and what it's based on. The US survey foot is based on the relationship that there are exactly 39.37 inches in a meter. Okay. And that will equate to like 3.2808 feet per meter, or whatever the number is. The international foot, on the other hand, has been redefined to mean 1 inch is exactly equal to 2.54 centimeters. And so do the math on that, and you'll come up with there being 3.2808, blah, 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 blah. And then about in the 8th decimal place, you'll see a difference in the numbers start to come up. Okay, so what this means for us is that we're still typically going to be working in US survey feet units, but it doesn't really apply when we're getting a drawing and we're trying to elevate it and get it built out on the ground. We can probably use either one. But if you have, let's say your survey crew goes out and they're staking out things, or they're doing their construction layout, or they're identifying control points or what have you, and they're using, say, GPS equipment, if that GPS equipment is configured to use the international foot, then you would want to match what they're using. If they're configured to use the US survey foot, again, match what they're using. So again, and it's sort of like when we were supposed to have switched to the metric system. Remember back when you were in the 3rd grade and they told you, oh, we'll be switching next year. Of course, that was when I was in the 3rd grade, which was a lot of years ago. And America just never has quite gotten around to doing the switch. So I'm not sure that this is really going to change, but I know that all the powers that be say it's going to. All right. So again, just default behavior. And to start me off, in this particular case, I'm going to say I want to use 1 inch equals 20 foot as my working scale. Now, what this means is this. If I have something on the ground that measures 200 feet or 200 meters or 200 angstroms, whatever it is, in the drawing, I'm going to create that to be 200 units long, always 200 or 100, whatever it happens to be. I'm never going to be changing the actual size of these entities. The only thing this is going to do is set things like text heights and symbol sizes, symbol heights, as if I'm going to be plotting this design at this scale. So if you look at this symbol size 0.1, text size 0.08, those are like plotted inches. So I want my text to be 0.08, or just under 1/10 of an inch tall. So at 20 scale, that's going to be 1.6 feet on the ground. And that's what AutoCAD or IntelliCAD needs to know. IntelliCAD can't take that 0.08. It doesn't know what you mean by that. It would make a piece of text 0.08 feet tall on the ground and you never see it. But what Carlson does is it takes these numbers here and it multiplies it by this number to create the number, in this case down here for my text, of 1.6. And that's what it tells IntelliCAD to use. IntelliCAD creates the text, it kicks it back to us. But if we measure it on a piece of paper after we plotted it at 1 inch equals 20, we would see that it's 0.08 of an inch tall. Okay. Then we have a line type scaler. That's just it's a factor of how often to repeat a pattern in a line type, like these dashed patterns over here that you see in the drawing. A symbol name by default. If I click that set button, I can see a bunch of different categories: trees, inlets and manholes, points. And here's some points that I have actually created, these custom points. But right now, my default symbol is set to SPT9, and that stands for survey point 9. That would be the symbol that is going to be used by default for any points that I create. Now, looking over here to the right now on the point, prompt, and label, I've got these attribute IDs, and we'll talk about these when we get to the point section a little bit later. But I'm using this ID2. It has a point number, elevation, and description, and it's hard to see there in that little preview, but that shows you what it would look like. If I switch that to 1, which I think is the default, notice the point number scoots over, elevation is off to the right, and description is scooted over. So what happens when you draw a point with that attribute ID? You'll see the point number centered above the point, the elevation is off to the right, even with the point, and the description is centered below the point. If you choose number 2, they're all off to the right, left justified. If you switch to number 3, point and description are centered above and below, but the elevation is off to the right and it's kicked up at a 45-degree angle. That's a very common format when you see a topo map with a spot elevation on it. They'll kick those elevations up at an angle just to indicate that that's a spot elevation. So there's, 10 different ones. They change the order and whether they're italic or straight text. So there's elevation on top, point number to the side, description on the bottom. So that's just, again, the default that you are setting. And then you're going to use or not descriptions, elevations, and you're going to plot them on the real z-axis. I recommend always having those on. You can turn those off if you need to later. And I always label my elevations even when there's 0. And then angle format, I'll use bearings, my point numbers. I'm going to use point numbers and choose automatic point numbering. Now, numbers, again, remember, can be letters intermixed. So like a 5, a 5A, 5B, 5C, or even a 5A1, a 5A2, a 5A3. And it knows how to sequence all of those as it goes through. And this automatic point numbering, what that's going to do is anytime we need to create points, it's going to go to that first available point that's not assigned yet, use that as the next number, and then increment every new point it makes. It just keeps going to the next available. Otherwise, if you don't have that on, you have to supply that point number every time it wants to create the point. So it's very convenient to have. Vertical angle mode, all of these things are as if you're reducing field notes. We typically won't be doing that with our type work, so I would leave that set to none. The drawing setup source, I'm going to use a drawing template as my starting drawing. That's what you saw as we stepped through that new drawing. And then display non-Carlson drawing units upon opening. So if we had a file, say, that was identified as an architectural file and they're using architectural units, it will give us a little display that says, hey, you're not in your standard units, and you would know to go and switch them. And then finally, on the coordinate system, grid versus local, and a grid is going to be these state plane definitions. All right, and so we'll talk about that and a lot of times if we're taking a PDF file and creating it, we're just going to be on a local system. But we're going to start things out so that we can use this, and I've got a predefined, user-defined, and right now I'm pointed at my NAD 83, North American Datum of 1983, the 1986 adjustment for Pennsylvania, and it should be Pennsylvania South. So I'm going to look for USA NAD 83, 86, Pennsylvania South. And that should say South, it's because there's 2 zones in Pennsylvania, but you'll see that in other places when we start things up. And what that's going to be helpful for is if we do have actual points coming in from the field from the layout guys, they're going to be usually referenced to state plane coordinates. So we're going to get them right where they're supposed to be on the ground, and then we can overlay aerial imagery and take other surveys and merge them all together, and they're all going to fit. We won't have to pick things up and move them and rotate them and scale them. So that's going to be what we use to start things off with. So we say, okay. And then the last one we want to look at, and we'll do this after lunch because we're just a little bit over here. We want to say these general settings, and here's where we're going to spend a little bit of time primarily over here on this object linking, so you see how that behaves and whether or not, and to be aware of it as to how things are created, at the time they're created, whatever the setting is on one person's computer governs that object's behavior. And even though you've got it maybe different, that object's already created with it in one condition. And so knowing what these do and how this works is going to be sort of beneficial for us here. Okay. So now what we'll do is I'm going to cancel that. We're going to come back after lunch and pick that up. So let's go ahead. I'm going to choose exit. Now you're going to see this because I did something in my drawing setup. Do I want to apply any changes I made to this current drawing and future drawings, or only to future drawings? Well, I'll just say future only. I'll leave this drawing as it is. Right now, it's just a throwaway drawing. So when we come back after lunch, we'll pick that up and we'll see about that, the startup drawing wizard, what it's going to do for us, what those settings are going to do, and then we'll jump into the points and stuff and get some practical application and examples here. So any questions at this point? Everybody good?
Be shy.
Okay. All right. So we're going to go ahead and we'll take your full hour. So let's come back at 10 after 1 to pick back up. And let me go ahead. I'm going to stop my screen share. And I'm going to stop my recording. I'm glad you caught that. Let's see. So now I want to stop this transcription. I thought when I canceled the transcription that it took the recording. Thank you for catching that. So yes, now it is recording. My apologies. Okay. So because we can't take that arc and stretch it up into a different plane and keep it as an arc, it needs to approximate that arc with these series of segments. And if you look at that series of segments, which are here, and you look at, let's see if I can get these two endpoints still within the screen. So you can see a deviation from the original arc. That red arc is still an arc. It's down in the plane of the starting point. So this distance right here, this separation at its midpoint there, is what is governed by this Carlson configured this maximum offset. And so I have set it to be, I want to use that method and create however many segments you need to create so that the maximum offset is always 0.02 of a foot or less. Okay. The other option would have been chord length at 1/4 foot. And so that would have made these that would have made these segments to be 0.025 feet long. So my preference on those is to set that maximum offset because I know that's how close I'm going to be to the original arc, no matter the amount of curvature. So if I have a really steeply turning curve, if I use a segment length, I could get more separation here than I necessarily intended. Whereas if it's a very long, flat, broad curve, and I still use that segment length, I'm going to get more segments along there than I really need. Okay, so that's my preference on these. Now, what this means is this. When I go to model this into a terrain model, every one of these little points is going to be the corner of a triangle. So if I were to model, say, that red arc, I would get a corner here and a corner here, and I wouldn't get this modeled very closely, but because it has different elevations, when I actually model this, each one of those points is going to be the corner of a triangle all the way around it, both sides left and right. And that's going to help define that surface as it traces along that feature. And it connects to other features that might be drawn over here and connects those corners up to be parts of those triangles. So when we convert that in, that's what it means when it says reduce arcs in this settings Carlson configure general. This remove arcs reduce method, I choose maximum offset, so I'm choosing that that's always going to be within that distance. Now you may see some cases where let's make that say 5 feet this time, just to show you the difference. And let's take this red, we'll take that red one. We'll move it down here a little bit. And let's turn that into a 3D by start and stop, or start and end elevation. We'll start here and we'll call it, we'll just say 102 to 114. That's approximately that. Now, did you see that? So that's what you're left with, because that distance from where the original arc was out to here is that 5 feet that I put in there. So if I undo that, and if I go back to my settings, now let's put it to something ridiculous like 0.00001. And I'm going to right click configure, or right click repeat 2D to 3D. I'll select this from 102 to 114. And now look at it, I've got all of those little segments. You see there's many more than are in this one. Now what that means for us is if you make that number too small, even though the visual fidelity of this resulting 3D line is a lot closer to what the original arc was, remember, each one of these points is going to be the corner of a triangle. So you're going to get thousands and thousands of triangles along this feature, whereas you might have, I don't know how many points are in there, 50 along that one. So you don't want to make this so small that even though it approximates something better, you want to keep it something that's livable. So I figured 2/100ths of a foot off the back of a curb, I'll be able to build that. It'll still look like a circular arc, but it will be what I won't get quite so many triangles. I'll get a more reasonable number of triangles to represent that surface, and I'll keep it simpler so it doesn't hog up my machine and take too much processing time. Okay. So that's what that setting does. And you can work on that accordingly. I think that, excuse me, I think the default, what that used to be, was something like 0.001, something really small. And it made for very, large surfaces. So I like to think of it as a practical number. So if I say, 2 100s, I can, hold my fingers apart and see what 2 100s look like, and I can live with that as my approximation. All right. So now on the object linking, we can see what these are going to do, and you can make sense of what they say. Link points with a coordinate file. And again, remember these Carlson points that we've been talking about. If we look back here, there's going to be these things that look like, maybe a symbol, a point number, an elevation, and a description. It's going to look like this right up here, for instance. Those are actually composed of a CAD point, which is just a standard CAD entity, but also a block that is the symbol. And a block is just a little miniature drawing, and another block that has the labels on it, or what we call an attribute block. Those are the attributes of the point number, elevation, and description. Now, when we say link points with coordinate file, that means if I've drawn some points into my drawing, either created them in the drawing or I read a coordinate file and drew them in the drawing, if I should move the point in the drawing, it's going to automatically go back and update the coordinate file. Likewise, if I change the values of the point in the coordinate file, it will update the drawing's position of that point. Now, that used to be a switch that gave you no warning. You'd have to know how it was set to know how it's going to behave. So once you drew a point into the drawing from a coordinate file, you could, if that switch was off, you could move that point in the drawing, but you wouldn't affect its value in the coordinate file. And then you could go back and redraw the point from the coordinate file, and it would go back to its original position. A lot of surveyors in particular liked that. When they drew a bunch of points, it would all be clustered around one area and sort of crowded up the drawing. They would just grab the points in the drawing and move them out of the way, because they knew they could always go back to the coordinate file and redraw the points. Now, the problem is this. When the points are created in the drawing, they are going to be governed by what this switch says to do. If it's linked, if the switch is on that says link them, and I draw them in the drawing, that's the way the point behaves. Even if I change this switch to uncheck it, it doesn't change that point. That point was created with the switch on, so it stays behaving in that fashion. Likewise, if I have my switches off, I work on the drawing, I dump a bunch of points in, and somebody else picks up the drawing and they've got the switch on and they think that they're going to be automatically updating. And if they move the point, it doesn't update the coordinate file like they're expecting it to do. So that, you can see, caused some problems, particularly for surveyors as they're putting in a bunch of like property corners. They move a point around just a little bit, thinking that it's either linked or not. Then if they go back later and somehow and they redraw the point or whatever, and if it's in a different than expected location, they wound up having some problems with their boundaries, with their property boundaries, because they get out of sync. Now, in recent versions, however, regardless of what that switch is set to, anytime you move a point in the drawing or change a point in the coordinate file, it's going to pop up a warning that asks you if you want to update the other, because it'll say the screen location differs from the CRD location. Do you want to update? And you can say yes or no. They put that little warning in there because of that problem. Okay, so that one's not as crucial. Linking line work with points is if we draw a figure with a Carlson draw command, which says pick a point or a point number. And if we use point numbers, basically we're assigning the vertex of that drawn figure to that point location. And if we should move the point, it's going to pull the line work with it. Okay, that particular vertex is going to follow the point. And again, it behaves that way based on what the switch is set to do at the time of its creation. Okay, so that, and we'll see some examples of it in just a second. Likewise, linking labels with line work, not so crucial. I'd like to leave all of my linkings on, for instance, but when we say link labels, what it means by labels are what are known as annotations. And the annotations are going to be created from commands on the annotate menu, where we can label the bearing and distance and areas of closed figures, things like that. And then if it's linked, if those figures should get reconfigured graphically on the screen, it's going to automatically recompute and redisplay those labels. If that linking is not on when you annotate it, then they won't be updated. Okay, and again, it doesn't matter so much when you have major changes that you can see. It's those little bitty motion or position changes that aren't necessarily that visible out at a high elevation, and you might expect the labeling to change, and it doesn't necessarily, in which you would just go back and relabel it. Now, if you simply type in some text and lay it down beside it, that has no effect on it. It has to be an annotation. So it's something that a command will read the geometry that's drawn and label it accordingly, whether it's, putting the elevation down on it or the bearing and distance or area of a closed figure, things like that. Okay, or lot numbers if you're doing a subdivision design. So that's what those linkings do. Now, linking line work with center lines, we'll see that in action here too, is whether if we turn some of our line work into an alignment, a center line file, then it's a two-way link. If we grip edit the polyline by just, say, selecting, an object and then changing that, that's going to go into the centerline file if this were turned into a centerline and update that centerline file. Likewise, if I change the centerline file and made this, say, a short length, then when I exit the centerline file editor, it will redraw that line work that was associated with that centerline file. Okay, so let's try a couple of these. If you go to Settings, Carlson Configure, General Settings, just turn all of these on. So now they're linked, and let's take a look at how this is going to work. So just go out in some part of your drawing, and we're going to say, draw a 2D polyline. And let's, first of all, let me change this layer so I don't have to keep changing the line weights. I'll make that 0.5. There we go. All right, so now we're going to draw a 2D polyline and just click OK and click some point in space. And now let's put some distance on this. We're going to type D for distance. And it wants to know what distance do I want to use. And my unit feet is in my angle bracket. You can see it in the options there. That's going to be what it assumes unless I type M or C or L or R to use these different units. So let's just make that 100 feet long. So I'll say 100. So now it knows how far, but it needs to know the direction. And you can go at the same angle as a line, or you can pick it on the screen, or you could type angle, or if you type cursor, it's just going to go to wherever your cursor is sitting. But if I choose angle, now it wants to know an angle code 1 through 9. And look, this is why I had you open up this list, because it tells you the codes right above here. So I'm going to go an angle code of 1, that's to the northeast. So now it wants to know, all right, what bearing do you want to go in the form of degrees, period, minute, minute, second, second. So let's go 45 degrees, 30 minutes, and 15 seconds. So that's 45.3015. We'll hit enter. And now there's that line. And it went that distance. Now it's asking me for another distance. Well, if I'm through putting in distances, I'm going to choose this quit button, which doesn't quit the command. It just quits the distance portion. And so now it wants to know some other numbers. So I've got a sense now that's 100 feet long. I'll make one like this, maybe come down here and come over here. And now I'm going to type C to close or choose it from my option. So now I've got a closed figure. So now what can we annotate about this figure? I can label the bearings and distances, and I can compute the area of this, and they're going to be on my annotate information or annotate menu. So if I go to my auto annotate, and it's going to pop up a menu here, and I'm going to choose my angle, which is the bearing. It's going to be on the row number 1 above the line. And my distance will be on row number 1 below the line. You see a little preview off to the right. So I'm just going to take that as my default. And I'm going to choose the figure because it says select the entities. Now I selected it. It says entities in set 1, and it still asks me to keep selecting entities. I'm through selecting. I'll just hit enter. And now you can see it has labeled around my figure. Now the linking, well, let me see if I can do the area. Does it have it here, area labels? Let's do an area by closed polyline. We'll also do that one. We'll just take a single area, no report, label the area and automatically place it. I'll say okay, and I'm going to click here. And now I've got so many square feet, which is equivalent to so much acres, plus or minus. Notice it echoes all of that on the command line. It also tells me I've got a perimeter of 815 feet. It's interesting that it's exactly that. Okay. So
Where did you
now
find that? Where did you find that area calculation? Is under annotate.
annotate, and this is in the area labels, and I chose area by closed polyline. Now, in the other modules like civil and survey, there's a separate area menu, separate from the annotate menu. But since you're mostly going to be working in your construction module, that's where you would find it. Okay. Now, we're going to do that same thing but I'm going to select my figure. I'm going to right click the mouse and I'm going to choose copy. And I'm going to click a point here and just move it over to here and hit enter. Now, I'm going to go to settings, Carlson configure, general settings, and I'm going to uncheck link labels with line work and say OK and exit. Now I'm going to repeat the same process I did here. I'm going to say annotate, auto annotate. I'll keep the same defaults. I'll say OK, choose my object, finish my selection. So it's exactly the same. I'll go to annotate and I'll choose area labels, area by closed polyline. I'll take those defaults, choose that, and now I'm done. I've got exactly the same thing. Now watch what happens though. If you select one of the polylines and you then move the vertices, I'm just going to grab this is called grip edits. So when I grab the grip, you see it recomputes the angles and the distances and the area, but that's because that linking was on. If I select it here and move it, see what happens? Now, how would you resolve that? Is that you would simply either, erase all of these labels and go back and repeat it, or in your annotate, auto annotate, there's a switch here that says, and I guess it's in my general settings. I'm going to go down here, hit the general settings. And right here, there's a switch that says previous labels, and it says erase. Now, if I said retain, those would stay and it would re-annotate. But because it says erase, now when I choose it, it knows the labels that were created previously. I've now selected it. I'm going to finish my selection. So it erases those and recomputes them. And then I would have to do the same thing with my area labels by closed polyline. And I don't know that this will, it may not erase the old one. Yeah, it did not, but it recomputed it. So I would just then select these and erase them. Now here's something else to keep in mind. These labels, okay, they're from the annotation. But if you look at their settings, look up here in the properties, that's an MText entity. That's a standard CAD entity. I can select that and I can move it around, do the same thing here and move this up here, for instance, if I would rather see them like that. There's nothing that keeps that from happening. I can freely move these around because they're nothing in the world more than pieces of text, even though they were created with that annotation command. You're free to do anything with them, just like a standard piece of text, as if you had just typed it and put it along that line. Now, if I were to go back now and, tweak this a little bit, it's going to go back and erase those and redraw them according to those settings. So that's what happens with linking your labels with line work. Now that would happen for that, or if you put the stationing along a center line of a road. Let's look at this link line work with center lines. I'm going to come out here and I'm going to draw a 2D polyline. I'm going to say okay, and I'm just going to go click, 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 click. What is that object? It's just a polyline. In fact, if you were to double click that object, notice down on the command line, it went into the p-edit command, the polyline edit command. That's standard CAD edit command. But if I turn that into a centerline file, I'm going to go to my roads menu now and choose polyline to centerline file. And when I do that, I'll run that. It says, all right, give me the name of a centerline file that I want to write. And I'm right now, because I haven't never saved this drawing anywhere, it's just starting me out here in Carlson projects. I'm going to look over here, my subfolders, and I'm going to go into my Middlesex training folder, my data sets for civil class, and I'm going to call this one example for links. .cl. That's going to be my centerline file. So now reading my prompts, and get used to always looking down here to see if it's prompting you for something. It says select the polyline that represents the center line, and it tells you that it should have been drawn in the direction of increasing stations. Well, I'm going to select this. It shows me its direction. It gives me the option to reverse it if I need to, but I don't, and I can give it a beginning station other than 0, 0, or if I just hit enter, that's going to be the starting station, 0 plus 0, 0. I'll hit enter, and it computes a bunch of things here. The line intersection, then it says press enter to continue. So I do so, and that finishes the command. Now, if I select this, I see in my properties, it's still just a standard polyline. I could even type pedit, which is my standard IntelliCAD polyline editor, select it, and there's those same commands. But now if you should double click it, it pops up the centerline editor. Okay, so this might be, say, manhole to manhole type of alignment. But if this were a road, I'm going to need to put some horizontal curves in here. So if I look in my editor now, I've got these individual pieces. So I'm going to sit on this incoming tangent. I'm going to come down here and say fit a curve. And I'm going to fit that curve with a radius of 100. It calculates all these other things. So you may know some of these, but not the radius, and it will calculate for you. I'll say, okay. And so that's going to put a 100-foot curve in between those two lines. Let's say save. Now, when I hit exit, watch the screen. You see how it put that curve in? Now, that now is a polyline with a tangent piece, a 100-foot radius arc, another tangent piece, another tangent piece. What's another way of putting an arc in between these two pieces of tangent? Those of you with AutoCAD experience. What CAD command could I use to put a curve in here? But the fillet command, and that would be on my edit menu. This is where most of my CAD commands are going to be found. There's a fillet command right there. That means you're going to put a fillet of a certain radius between two straight pieces of line work. So I choose that command, and it says fillet, choose a polyline, radius, trim, settings, multiple, select the first entity. So I'm going to be picking this one and this one, but read the line above where it says the current settings. The mode is set to trim, so it's going to trim back from the point to where it puts the curve in, and it has a radius of 0. Well, I don't want a radius of 0, so I'm going to choose the radius value, and let's make this radius, say, 75 feet. I'll say 75. And now it still says select the first entity, so I'm going to pick the incoming tangent, pick the outgoing tangent, and now there's a curve in here with a radius of 75. Well, with our linking on, remember, we did one where we put the curve in the centerline editor and it updated the drawing. We've now updated the drawing, but what about our centerline editor? you could choose from the roads menu, choose the centerline editor, pick the file, or you could simply double click the polyline. It loads the editor, and now you see what, there's that curve of 100. And this curve, if I double click or choose the edit button while sitting on that curve, you can see the radius is 75. Okay, so that's how that works. And even if I go here and let's bring this, I'm going to pull this point back to, say, right in here. And let's pull this point, say, up to here. Now, got a non-tangent situation, but if I double click that, let me see here. I guess because it updated the radius. Oh, I see what happened. Okay, so it maintained the radius. It maintained tangency in the definition. So if I undo that, let me see if I can get an obvious change. I'm just going to pull this down like that. Now, there you go. When I grip edited that and moved it here, you can see the original grips are still showing, but it maintained the tangency around here to finish that alignment. Now, if I double click, I now have that matching what's on the screen. There's my curve, and it's still at a 75-foot radius, but this line length has now changed to whatever it used to be. Okay, or from whatever it used to be. And again, you could label those with stationing roads. We want to see sections. See where they put stationing. Oh, here it is, station and polyline or centerline. So I'm going to station, I'll just take these defaults. I'll choose the centerline file, and there it's put the station values according to those, whatever settings were in that dialog box. Now, if I were to choose this edit and bring this back down like such, it has updated the centerline file. The labeling did not follow it, even though it's linked on, until if I were to edit that file, then save and exit, it recomputes and redisplays the labeling along it. So that's how that linking works. Okay. Now, let's go back down to our little example down here where we had this as a 3D figure. And let's just draw a 2D polyline. Right beside it, we'll come over here and go to here. We'll say arc. We'll come out here, and then we'll say line, and we'll come out here. So we've got something similar to it, but it's a 2D polyline. Now, what can we find out about that particular feature? Let's say I wanted to know the elevation of the middle of this segment, because it changes from, if I look down here at 114 to 118.85. So somewhere in the middle, you could do the calculation, you could find that out. But if I wanted to find out what that elevation is along any particular given point, There's a couple of things I can do. And it's not going to give it to me if I look in my properties. Now I can step through the individual vertices as I'm doing here in the properties. And I can get to that one that was at 114, and the next one to it is 118.85. I don't get any information about that. So there's a series of commands on the inquiry menu because I want to find out about things. So I'm going to ask questions about them. Therefore, I'm going to look at my inquiry menu, and I can say, look for a point ID. Now, it wants me to pick a point or a point number. And if I want it exactly in the midpoint of this segment, I'm going to have to snap to that midpoint. Now, I'm hovering the mouse, and you see that little marker pops up, and it says midpoint. That's because I have my snapping set on to be midpoint. If you do not, you can still just hold the shift key, right-click the mouse, then let everything up, and now come down here and say midpoint and pick that segment. And so it identifies that midpoint, shows it to me down here, the northing, the easting, and the elevation, 116.43. Okay. What else could we find out about it? If we said inquiry and said polyline information, and if we picked our polyline here, it says, well, that polyline has a length of 236.75 feet. It's got a slope distance of 238.34 feet. So it's longer because it goes at a slope. It has an average elevation of 112.56, has an average slope, 7.96%, an overall slope, the same thing, and it is open. So it gives us some information about that. If we repeat that command and choose this one, see, it only has a length and a constant elevation. It doesn't have all that slope information. Well, what about what happened here? And the reason that we're no longer at 5%, because remember I shortened up that distance here, so it kept that from 100 to 118, and so our slope steepened up. But what can we find out about it at various points along the way without having to stop and snap and do all kinds of different things is on the inquiry menu is a command called drawing inspector, on or off. It's a toggle. So if I turn it on, it tells me down on the command line, inspector is on, right click to activate a pop-up menu. So if I right click the mouse, these are all the different things that I can see about things in my drawing, and they will pop up when I hover the mouse. So a couple of things you want to turn on is, first of all, down at the bottom, you want to enable the tag display. Make sure that's checked on. And then you could choose individual ones here like layer name. And you can keep doing this and say the entity type. And you can do those one after the other, or you can right click and choose the options dialog. And so I'm going to turn off the type. I'm going to look at the layer name, the elevation, and I'm going to display that polyline data and even the polyline direction. So I'll say OK. Now, because it's running and I can run other commands in the middle of while this is running, and if I hover the mouse, it's going to pop this up. So it tells me the layer, the elevation, the horizontal distance, the slope distance, the elevation at the start and the end, the slope as a percent, the slope as a ratio, the total distance, and the current distance means the distance of that particular segment. And here and now I'm in an arc. And I'm sorry, the current distance is the distance along from the start, rather, I'm sorry. And then it's open. Now, if I hover over this one, notice that elevation is constantly changing everywhere along here. So now I'm on this segment down here, and it's not going to those individual pieces. It's just reading that along as I go, and it's reading that slope. There's that 5% slope. I guess it did keep that 5%. Now, this segment was at 32.75% because I shortened it up. Once I get into this part here that I didn't change, it's back at that original 5%. And so a lot of information, if I hover over, these circles or this particular figure, notice it reads the area in square feet and acres, and you see that matches the actual label. If I look at any given segment, that tells me that distance, 105.574. Okay, it's flat. Same thing here as I move this around, come into this circular piece, it tells me the arc length and the radius. There's my 100-foot. There's my 75-foot. And it gives you one other thing at the bottom. It tells you that it's associated with a centerline file, whereas these are not. There's no file associated with it. It was just stuff drawn in the drawing, but that has a file association written to it. So you can right click and choose turn off drawing inspector or go back to inquiry and just choose the command again, and that will turn it off if it's on. And then you're back to having, nothing reported get in your way. And so it's a very useful tool, particularly if you're trying to identify layers that things are on, or whether or not it's 2D or 3D, all kinds of different things that you might want to be showing. Okay, so now we're going to take a look next at these points. I'm going to come back to this to see what we can do with these points and how we can work with these Carlson points. And again, right up here on page 13, this opening paragraph, it tells you, what good are points? Okay, they can be useful to display location, give you other information, point number, elevation, description. But here's the big benefit is that you can identify points based on numeric ranges, 5 to 13, 21 to 25, 30, 35, individual point numbers, ranges, and it will even compute backwards. If I said 25-20, it would go from 25 to 24 to 23 to 22, 21 to 20. Okay, so that's a really productivity enhancer that if we know some edge was captured by our surveyors, that we needed to create that edge based on those points that they brought in from the field, then we can do that simply by point numbers. So let's take a look at that as an exercise here. So let's go back to our drawing, and I want to select everything in my drawing. So there I did a zoom extents by double clicking the wheel, and I noticed that, there's that stray point down there again. See that point? So I could have got rid of that. Now there's zoom extents, there's everything, but I want to erase everything that's in here. So how would we do that? First of all, it's just going to be a CAD command so I can pre-select everything. And remember, if we click a window and go to the right, it all has to be within it. If we click and then go to the left, all it has to do is touch it. So either way, select everything there, or you can type the command erase, and in response to select entities to delete, you can type the keyword all. So that's got everything. I hit enter to finish my selection, and now everything's gone out of my drawing. All right, so back to our exercise, we're going to set a coordinate file to exercise 1 coordinates. We're choosing this point, set coordinate file, and then choose, then we're going to draw the points. So let's go to points and let's set a coordinate file to be associated with this drawing. And again, you don't even have to have one, but I'm going to choose, if I can get it to come up here. There we go, set coordinate file. And it's either a new file or an existing. This one happens to be existing, but I need to navigate to my folder. And right here it is, my Middlesex training drawing data sets for civil. The reason it wasn't pointing to the right place is because I haven't yet saved the drawing. I haven't told it where the drawing lives. And right now it lives right here until I save it, and then it would go to that place by default. Well, I'm going to choose this exercise 1 coordinates. Now, one thing I want to point out, when you're looking at these files and working with these on your own, you're going to see maybe some files here that start with a period and an underline. You may safely ignore those files. They're just little, what are called resource forks, and they're part of the files that happen because I'm doing all this stuff on a Mac computer. You may or may not see those. If you do, there's nothing in them, so that's not the right one to use. But if I choose this one and I see in my little preview, I've got 22 points in there. That's the one I want. And by the way, you can safely just erase those from your file explorer. You can get rid of all those. So exercise 1, choose open. Now nothing's happened except that I've told it, and I see up here on my command line, I've got a coordinate file called exercise 1 coordinates. My drawing still says drawing 2. So let's go to the file menu and save as. And let's navigate to where our data folders are. So I'm going to go down here to Carlson projects, open that up. I'm going to go to my Middlesex training folder and my data sets for civil class. And I'm going to call this one points example, for instance. All right, so now I look at my top of my screen and I see I've got a coordinate file called exercise 1 coordinates. I've got a drawing that's called points example. And if I were to go back to points and say set coordinate file, notice now it comes to the right location because it's following that drawing location. Okay, but I've already got it set. Now, nothing's in my drawing, but I have this file and I can go to my points menu and list points. So when I list my points, I can give it a range or all and say okay. And I can see here that I've got this actual point file. Tells me what the point file is. It gives me northings, eastings, elevations, and descriptions. Now notice these coordinates are just made up coordinates. They're wherever they happen to be. Mins and maxes, total number of points. So that's in my file, but they're not in my drawing. So how do you get them from the coordinate file into the drawing? And that's also in the points menu, and you're going to draw or locate points. So when you do that, you're going to get this dialog. And it's going to take a couple of things like this point symbol from the defaults and the point defaults, or I can change it on the fly here and maybe switch it to, let's use X's. I will turn on my descriptions, elevations, locate on the real Z axis. I'm going to use point numbers, automatic point numbering, so it'll automatically increment. And it's going to start with point number 23 as if I'm going to create new points in the drawing, but I'm not. So this is not going to affect us. We're going to simply come down here and say, let's pick a layer to put these on, we'll put them on a layer called PNTS points. We can restrict it to description wildcards for descriptions. Right now, an asterisk means take everything. Any duplicates, erase the old ones and redraw them, or whatever you choose to do. And then simply say draw all. And when you do that, they all will draw in the file. And you can see them here as 0.1, 0.2, 0.3, 0.4, etc. And they have elevations. They do not have descriptions because if you look at our list points that we just did, you can see there are no descriptions in those points. Now, how could you put a description on a point? You need to edit the point, and you do that several ways. You can double click the point, and it asks you for some general information here with coordinate values. You can change the symbol, you can add some notes, put some GIS data, images, etc. And I'm going to go here to the general section, and notice there's two fields for descriptions. So if I say point number 1, if I call this one a control point, let's say a CTRL, notice I could make that non-surface, so it would not be calculated in a surface if I chose to do that. Say it's the top of a fire hydrant, and I don't want to compute the top of it in the surface, so I would do that for those. So CTRL, and I'll say OK. All right, so now nothing happened. If I double click point 2, I see the same blank blank. If I go back and double click 1, it has a description in the coordinate file, but it doesn't have anything in the drawing yet. So I could say control point number 1 as a drawing description. I'll say OK, and you'll see that associated. Now, that's not anything that you're going to need to really keep track of, other than to know that there are two possible descriptions. And this is set up this way for the surveyors in particular that use a feature called field to finish, where you could have a particular code, like you might say CT for control, or CP for control point. And that code could then say, when you draw it in the drawing, use this description, and you might spell out the words control monument. So that's why there's two different descriptions there. But you can also go to the points menu and edit the points, and it brings up all of the points. And there you see there's control. And here, just for yucks on point number 2, I'm going to call this one control point 2. I'll save and exit my editor. And so now, because I edited it with the file editor, it went back and redrew the point into my file. This one still has that double description, but I can recreate what's actually in the file by just go to points, draw locate points. And this time I'm going to say draw a range of just 0.1. I'll hit enter and hit enter to finish. And so now it reads the coordinate file description and puts it back in my drawing. Okay. Now, for those of you who may be wondering, why do my points look like this and not like this? If I go to my text styles, if you do not have, let's see if I can find the right, yours might look like that, those sort of squared off letters. That's because there is a point style, and I'm going to choose that from either draw, text, set style, or from this lovely little button called Layer Control, also available under View, Layer Control. It not only lets you control the layers, but you also can control all of these different aspects in the drawing, one of which is text styles. And now the first time you use that, PTXT, you can come over here and set a particular font that you might like, and I'll choose Calibri Light. And now those points are drawn using that PTXT style, which is defined with that font to use. The reason mine had it there is that my drawing template had pre-built that text style, and that's what it used. If you have not pre-built it, it just builds it on the fly and assigns that other text to it. Again, nothing that affects really what you're working on or doing. Notice the attributes. I've got 3 things here. If I select this one thing, I've got a group of 3 things. I've got 2 blocks, one of which is a symbol, the other one is the attributes, the point, number, elevation, description, and the other is the actual point itself, the actual CAD point. So notice my attributes. Point number 1 is centered above the point, the elevation is off to the right, and my control is centered below the point. And that's because my point default, now this overrode what I had in Carlson configure drawing setup, where I used these attributes right here because my template had different choices. So it falls back on this point defaults. And so now instead of that attribute ID that I had before, which was 2, so now they're lined up on the edge, and a particular symbol. So I'm going to change that symbol now to be a plus mark instead of the X. I'll say, okay, nothing's happened because they're still there from the last time I did the command. If I simply go back now and draw locate points and just say draw, or let me change this layer now back to points and say draw all. Notice now they're all lined up on the left margin, and if I select it, I see it's on this layer called PNTS, points. And those attributes are actually on these layers. If I go to View, Layer Control, I see these layers. There's one called Points. That's where the whole thing lives. So if I freeze that layer, you see they go away. I'll thaw them. But here I've got point number, the point mark or the symbol, the elevation, and the description. So if I go to point mark and freeze that layer, and I'll look at my my freeze column here. Let me open that up, freeze thaw. If I freeze that, the symbols should go away. All right, the mark's not, but the description, the elevation, the point number, the entire point, that point mark should have gone. Oh, I know why it is. Because in my points defaults, I said separate layers. I said none, but if I said both, and now let's go back and redraw all my points. And now if I go back to my little layer manipulator, now I see my point mark. So I can freeze those off, freeze the elevation, the description, the point number, and the entire points. But see, when the points go away, the mark is still on independently because I told it to go to a different layer in my separation. Okay, so just some of the things you can do with points. Now, what about drawing those features? So let's choose another Carlson draw command. Let's draw a 2D polyline. Again, 2D. And let's put it on this layer. Final is fine. I'll say okay. And I can just start clicking points out here in space. And then where it asks me, it keeps asking me every time I pick to pick a point or point number. So with a point number, if I say 1-5, well, that's very quickly lets me go from 1 to 5. Then maybe I jump up to 10 and then went, say, 11 through 13 and hit enter to finish. So now I've drawn a figure based on knowing which points it's supposed to go through. Now remember our linking, Carlson configure general. We said link line work with points. So if I should move, say point number 4, I'm just going to select it. I'm going to grab that grip in the middle. I'm going to stretch it down here. Update the coordinates. That's also that linking. I'm going to say, yep. And when I do that, it pulls the line, the part of the line that's associated with that point, it pulls it along for the ride. Okay, so if that were unchecked, let me get rid of that one again. Go back to Carlson configure and uncheck that link. Then say enter. Okay, and let's draw a 2D polyline. We're going to go 1-10-13, enter, enter. And now, if I were to select this point, move point 4, and yes, I'm going to update it. Notice the line did not go with it. I don't think if I do update coordinates, yes. Yeah, so it doesn't pull the line with it because my linking was off. So understand how the links work and use them accordingly. And remember, it happens at the time that it's created. So I turned my linking back on. I think this will, yeah, see, it still doesn't do it because when I created the figure, it was not turned on. Okay, now that was a 2D polyline. What happens when you draw a 3D polyline? And this time we're going to turn off any of these check boxes up here, and we'll just use the current drawing properties will be fine. We'll say okay. And we'll do the same thing. We're going to go 1 to 5, then 10 to 13. And so now when I select that 3D polyline, let's look at its vertex elevation. You see it went from 101.35 to 103.50 to 105.86 to 108.25. You can see that right here in my properties. And as I step through those vertices, I can see that they have elevation. I can also see if I were to spin this model up, and all I'm doing here is I'm holding the shift key and I'm pressing and holding the wheel on the mouse, keeping them all held and then pushing around. So I see that my points have elevation. This original 2D had 0 elevation. Now it can have, let's say 101.35. If we select that and give it an elevation of 101.35, notice it goes up there and joins that elevation, but it stays that flat elevation, whereas those other points keep changing elevation. Come over here and hit my top view. And now I'm going to select that 3D polyline and erase it. And let's look at one more option here. If I draw a 3D polyline, so draw 3D polyline, and this time check on to prompt for elevation or slope. And notice a couple of other things popped up here. Here's an elevation adder. So let's say I'm putting these points are going to be, say, where I want my my water line to go, and I want that elevation to be 4 feet lower than these points. Okay, so I'm going to say okay, and it wants to know. I'm going to say 1 through 5, and then 10 through 13. And notice it's reading me all that data out there. And now if I look at my 3D polyline at vertex 1, I see I'm at 101.35. No, it didn't do the adder. Let me see. I draw my 3D polyline, prompt for an elevation adder, prompt for, I have to also prompt for coordinate point elevation. So in this case, that will do that. So if I prompt, and if I'm out here and I hit just an empty space, it says, what's the elevation? Well, let's maybe make that 100. All right, and now I'm going to go 1, 5. And you see that elevation adder on the command line right here? It's taking it as 4 feet below that, but it's prompting me to specify that elevation. So let me see if I do. Yeah, see, it's stepping me through each of these elevations until I get to, there's 0.5. Now I'm going to go 10-13, and I have to confirm each of those elevations until I'm done. And now, see, I went out here at 100, and now you see that point is 101.35, but this point is, look in my status bar, 97.35. This point is 99.5. That point is 101.86. So you see, it took that 4-foot differential, that negative 4 feet, and it placed it in space where those might be top of ground elevations. And I told it to position it 4 feet down in the ground. So there's all kinds of options that you can get out of these tools just with this kind of control that you're doing. You can also turn on a dual 2D polyline, and you could leave behind a 2D polyline on a particular layer, and it would actually draw 2 figures, one of them 2D, one of them 3D. And that's useful for things like if you're drawing again that road edge that went around the arc, it would keep a 2D version of it with a true circular arc, but also be generating those little segment pieces around that elevated arc. And the reason you might want to do that is to keep that 2D geometry available for labeling or figuring out, the radius of that curve, because once you make it into a bunch of arcs, or into a bunch of segments, it no longer has a radius, but you guys out in the field might need to know a radius so they can stake it for you. So that's useful from time to time to do that particular type of thing. Okay, so try your hand at a couple of those. Let's draw a 3D polyline. I'm going to uncheck those. So if I don't prompt the elevation, it's going to read the elevation and use it. I'll say, okay, now this time I'm going to go backwards. I'm going to go 18-14. And you see there it went. And if I were to go to inquiry and look at my drawing inspector and hover, you see the direction the line was drawn was from 18 to 17 to 16 to 15 to 14. And it has changing elevations all along it. So right here, I'm in this segment, and you see the Z start says 157.756. The end says 156.768. So it's reading the start and end of that particular segment as I hover. It's reading all of those values, the individual slopes along that segment. I'll right click now and turn off my drawing inspector and come back to where we were. Questions on any of that? Get a sense of how we can use these points and some of the things that we can do with them. And the reason that we might use them a lot is because of the ability to put in these point ranges. They're going to really speed up our drawing so that we don't have to jump to individual points. Okay. Now let's talk about something else that some of you new CAD users might not be used to and that I've been doing here earlier. If I say draw a 2D polyline, and if I want to draw starting on the end point of that line, well, if I don't have this on, and I'm going to, I would have to zoom in here and just try to eyeball myself to be real quick, but I want to go exactly where that endpoint is. And that's called object snapping. And that's down here on my status bar. You see it's called an entity snap settings. And you can double click it and toggle it on and off. You can right click it and choose settings. And so here are the ones that I use most of the time. And I keep these on. There's endpoints, so it's going to automatically find endpoints, automatically find center points like centers of circles or centers of closed figures. It's going to automatically find midpoints, and then it's also going to choose this one called extension. Okay, so what that means is now if I'm going to now start drawing this line, if I hover here, see the endpoint comes up. If I'm closer to the midpoint, it identifies that. If I get closer up here, it finds the endpoint. So I don't have to zoom in and out and try to get real precise. It's exactly on that endpoint. So it took that. I'll come here, maybe go up to the midpoint of that line, and let's go to the midpoint of that line, and then to the endpoint of that line segment up there. So those now reacted because of these settings in my snapping. Now let's suppose I wanted to go to a perpendicular snap. So I could do, I'm going to go ahead and erase this. And if I draw a 2D polyline, if I'm going to come from, say, here, and I want to draw the line that's perpendicular to this segment here. Well, I don't have it on, but I can hold the shift key and right click the mouse and temporarily, just for this one click, choose perpendicular. And now I point to it and you see it lines up perpendicular to that. And then maybe I go to the endpoint. So I'm back to these running snaps. And if I want to go perpendicular to this line now, I'll shift, right click, choose perpendicular, point to it, and there it locks up. Now, when I get, let's see, that's perpendicular. What does that say? Oh, that's the reason you're seeing that is it's perpendicular to the 3D or to the 2D. So that's why you saw those two things there. So now this is perpendicular to that, and this is perpendicular to that. So those are things that you're going to want to use. These snaps, and you can turn them completely off so that the snaps have no effect, or turn them on and then they'll recognize that whatever is set in your settings. If you need to temporarily choose one that's not set, shift right click does it, or you could have this toolbar called Entity Snaps. I'll put it back up here now. Put this guy back over here. And so this being out, I can see what is currently set, but if I need to change it, let's say this time I'm going to draw, say from the midpoint, and I want to go perpendicular to that. I can, again, right there's my midpoint, or I could go perpendicular, or perpendicular is not there. I can shift right click, or I can come up here and just temporarily click this once for perpendicular. Now it finds the perpendicular spot, and then I can go up and do it again if I needed to go perpendicular here. Okay, so with this toolbar, you can do it, or you can hold the shift key and right click the mouse and choose it. And it happens to be just for that particular point that it's asking for. Otherwise, all of these other ones are always in play and you don't have to select them. So if I'm drawing, say from the midpoint here, there it is, and I want to go to the end point up there, there that one is. Okay. So that's how object snapping works, and that's something that I would recommend that you get very comfortable using, particularly going to endpoints. I would recommend leaving that on most of the time and make sure your settings are what you want them to be. Now that extension works like this. If I go from, say, midpoint of here, and if I want to go to the extension of this line somewhere, if I hover and get that endpoint up and then sit in the endpoint and then pull this out, you see that extension line? That keeps me right on the same extension of that line. So if I were to extend this line to where it hits this line, it would meet right there where that endpoint is. Okay, so just a couple of settings. And again, it'll take you, some time to get used to that if you're new to it. But I would keep those close at hand, knowing, keep setting your settings, and maybe pull this toolbar, this Entity Snaps toolbar out and park it somewhere on your screen so you can get to it. Now, that brings us to talk about these toolbars here for a minute, since some of you are new to the interface. Again, I said that I don't normally use these ribbons, but if I did, you would see things like this, and then maybe, what would I look at? If I want to draw, here's some draw 3D tools, here's some draw tools. So there's your 2D polyline. So all these different commands, and they're nice if you like to use the ribbon interface. I don't particularly, because I haven't learned where those things are yet. It's just my particular preferences. So here's what I have out floating about my drawing space. And you can find that a number of ways. You can click in any of the blank space at the top, like maybe beside the menus or beside any toolbars. And you can choose to show a particular toolbars. These are the ones I have from Carlson. I have a couple of them from IntelliCAD. And notice there's IntelliCAD DGN mode, there's CG survey mode, but Carlson and IntelliCAD are going to be my two primaries. And I could come down here and just check them on and check them off and choose them. There's another way on my settings menu, or what we call toolbar setup. And this lets us choose which particular toolbars that we have out. And here, and you pull down at the top. So if I look at my IntelliCAD toolbars, I've got my IntelliCAD draw tools. I've got my entity snaps. That's this toolbar up here. My IntelliCAD draw tools are the leftmost vertical one. If I uncheck that, you'll see it goes away when I say OK. So it's now gone. If I turn that back on, I'm going to go Settings, Toolbar, Configure, go to IntelliCAD, and I turn on Draw. It's going to pop up at the last place it was, or it could be that it's out here floating in space. You can grab that little handle where you see those vertical dots and drag it around. You can dock it on the left, dock it on the top, on the right, or on the bottom, I think. Not gonna let me do it there, but you can also just reconfigure and let it float. And you can, make it into whatever shape you might want, make it vertical, do however you want to do it. Now, I typically put mine here vertically, and I put it beside. This one is it also says draw, but it's my Carlson draw tools. Okay, so back to settings, toolbar setup. Under Carlson, you see I've also got my Carlson draw turned on. And that's because occasionally I'll choose just a standard CAD drawing tool, like rectangle, maybe. Down here is also rectangle. So all of these have different ways. If I draw a polyline, that standard AutoCAD draw polyline brings up this command below. But if I draw a 2D polyline from the Carlson toolbar, it brings up all of these extra tools. Okay, so I'll show you which ones I have out here. Under Carlson, the Carlson menus, that's the one that lets me switch between construction module and civil and survey. Draw, that's this vertical one here that shows those drawing tools. Entity properties, and that's these up here where you can pull down and change the layer, the color, the line style, and whatever that has to be. Maybe transparency, whatever these happens to be. I've got a grading toolbar, and that's the ones that allow me to set my grades based on other things. It's like from the Elevate menu. Inquiry as a toolbar, now it's way over here on the top right. And the one tool that I use from there almost all the time, and really not many others, is the standard distance tool. And I keep that up there just because I've gotten used to seeing it there and where it's going to give me that. I've got Carlson layers, which is this toolbar, and it has certain things on it that the IntelliCAD layers does not have, like erase by layer. And then I've got polylines, which gives me a lot of editing tools for polylines on a toolbar here. Got standard, which is my new, open, save, etc. Surface, which lets me triangulate and contour and look at surfaces, view it in the 3D, all those viewers. And then my transparent point and selection commands, which are tucked over here on the far right. My IntelliCAD toolbars, I've got the draw, entity snaps, that's this one here where I can override those snaps. Modify, that's this vertical one on the right, which has all of the CAD modification tools, standard commands. And that's really all that I've got and what I'm using. Okay. Now, if somebody has something in your configuration, for instance, in your office, if somebody's got a nice arrangement and you might want to duplicate that, if you go to settings and instead of toolbar setup, if you go to toolbar manager, or even let's say you are upgrading to a different version, you can save a toolbar file and then load that. So if you saved yours and gave it to a colleague, they could load up that toolbar file and it would read the ones that are out and bring it back into your drawing. You can even load by program and it will identify all the different versions that you may have of Carlson software in these particular files that you may have saved. So you can transfer those configurations back and forth with that. Okay. So any questions on some of that? Get a sense the importance of the snaps and how to use them and why you should use them so you can make your geometry exact. Okay, let's see. What do we? There are no chats, okay. There you go. Put my chat back on so I can see it. I'm sorry. I missed that little front part of the recording. So that should give you a good sense then of, working with these points. Now I'm going to leave this idea of point groups to your own exploration. It's got some drawings here and it lets you create groups of points based on their descriptions. And then, you would then draw those points, for instance, all of the property corner group, and you just specify it by a group. You don't have to do a range of numbers because they all live in that same group. It's going to draw all those points in there for you. And then we turned off the layers for point number, description, and elevation. We just put the symbols down. So that is, another way of using groups. So I'm going to leave that to your own discovery. And then we're going to take our little break here in the mid-afternoon. And when we come back, we're going to start talking about building these surfaces, how we can use all of this information that we might have in the drawing, we either have to elevate that information so that we can then build a surface, or we have something already provided at elevation. So how do we use that to build a surface, and what do we need to know about it when we're building those surfaces? Okay. So questions to this point? Good. All right. I'll see everybody back at 3:15. and stop transcribing. Well, that's awkward. I wish there were just a button for each. Anyway, all right, I think we are, yes, we are recording. So here we go. All right, so let's talk about what it is that is going to be used to model these surfaces. And obviously, we want things from our drawing that have elevation. In this particular case, what I'm left with these 22 points, and I erase those 3D polylines, there's one it's 2D, but it's at that elevation of that starting point. So in that particular case, the only thing that would define this surface would be those points because they are at a particular elevation. If we have a drawing and it's basically flattened down to zero, it's up to us to either elevate those items to where they're supposed to be and then build the surfaces, or if you have a cooperative engineer on the other end of those designs, maybe they can send you all of that 3D information so that you can get things started. Now, that's not often the case. I realize that and appreciate that, but sometimes it is. And there's a number of ways that we can get access to that information. So we're going to take a look at some of that stuff. But first, let's take a look at what do we mean when we talk about terrain modeling. So we may have a drawing that looks like, let's say something like this right here. And we all recognize those as contour lines, and they represent lines of constant elevation along those lines, of course. And so that's going to sort of help us define that existing ground. Now we need that defined so that we can compute the amount of, excuse me, the amount of earthwork and materials and such that we need to either bring in or take away to get our designs built. So if we only look at this, we only have drawn elements in our design, in our drawing file, the only thing we know, let's assume that we've put them at the right elevation, then we know the elevation of, say, this line in here, and we know the elevation of this line here. But what do we know about the empty space in here? And the answer is, from a standard CAD drawing perspective, absolutely nothing. It's just empty space. So when we are going to model the actual surface, what we're going to do is use the information that we do have and allow the computer to fill in the information in between the things that we do know with its best approximation of what is actually out there in between it. Sometimes it would be exactly go half the distance between them and it's half that elevation. Sometimes that's the case. Quite often it's not. If you look at this particular feature that I'm tracing here, let's say that's elevation 1300. Well, according to this, if I go halfway from 1300 over to 1300, it's still 1300 in there, but it's not really. It might be 1301 out here. So halfway from 1300 up to 1301 would make that 1300.5. So it would actually come up and then back down going this way. But this way it would be interpreted slightly differently. So we need obviously more information than just drawn contours. Sadly, though, and I recognize this, sometimes that's all we get. So like, for instance, around this would maybe make this little flat area in here the same elevation as this contour line all the way around it. And it wouldn't change until it got over to some of these areas. So we need some way of helping that situation. And there are some things that will do it. Here's another prime example of over here on these edges where you see these little valleys along road edges and curb lines and such. You'll get a situation like this where it comes up this line, it comes down this line, and it looks across and it finds itself. And so it just assumes that it's that same flat elevation when it's not really. It's halfway between these two. So we need to either draw in a line that connects all of these things and elevate them so that the intervening elevation along this line is going to go from this elevation down to this elevation, and it would find it halfway in between. So we need to recognize those kind of areas, and that's going to be a feature that we're going to call a break line. And so nothing in the world more to break lines than this particular thing. It's on page 20 in your book, and right there's the rule. If it's an edge, so break lines are nothing more than edges. Okay, and so if it's an edge on the ground, we need to make it an edge in the data that we use to create that surface. Okay, hopefully somebody's already done that for us, in which case we can just use them. But if not, sometimes we have to use a little intelligence to make this happen. Now, here's why. If you consider this figure of 4 points right here, let's say the surveyors went out there and they surveyed these 4 points. When the computer goes to model that into a surface, it looks at every point that it finds, whether it's a Carlson point or a CAD point or a vertex along a 3D polyline, all of those little segmented pieces of that arc, all of those little endpoints, every single one of those points, it's going to sit on those points and it's going to look around itself in 360 degrees, and it's going to try to connect an edge of a triangle, or let's just say try to draw a line between where it's sitting and what it sees. So if I'm sitting down here in the southwest corner at this 110, I may look all around myself and I look up here and I see this point that's 100. And so I'm going to draw a line up there. I'm sitting down here and I look all around myself and I see this point at 110, and I'm going to connect that with a line. So the assumption is that the elevation changes linearly between those two elevations along that edge. So this goes from 110 up here to 110. So that stays, that's a constant elevation there at 110, but it drops down to 100 here. Now, I could still sitting on this point, I'm still looking around and I see this point over here. And so I'm going to connect a line up there. Now, once these lines have been connected, when I say we're going to draw a line, we're not going to physically draw it, but the computer is going to hold that in memory. And once that gets built, it's going to be a barrier. It's going to be a break line. It's going to break our triangulation from, let's say we're sitting down here in the southeast corner now, and I look all around myself. I see up here at 110, I can connect that line. I look over here and I see point 110, and I'm going to connect that line, but I can't see past this line that got created when I was sitting at this point. So I can't see this point over here at 100. I can't connect this point 100 to that point 100 over there, because this is in the way. And so that's going to serve as our break line, that particular function. This particular little figure, you can see, looks like a ridge line at an elevation of 110, and it falls off to the northwest at 100, falls off to the southeast at 100. Now, all of these little lines that it puts together all over the site, it's going to form triangles out of those points. And the reason it forms triangles is because a triangle is the minimum shape that it needs to define a plane as part of this surface. And it's going to stitch all of these triangles together into all these little bitty planes and facets and triangles to form that surface. Now, if you consider those same 4 points like this, in this case, maybe the computer sat on this point first at 100 and it looked over and it found this point and it created that line. So now 110 can't look across and see 110, but it still formed these edges. But now this particular set of 4 points represents a valley running down here at elevation 100, and it rises to the northeast to 110, rises to the southwest at 110. So with only looking at the points, there's no way to determine whether that figure does this or whether that figure does this. They are equally valid, and it really only mattered. The only way that would resolve itself, or it wouldn't resolve itself, it just basically it's a first come, first served basis. So it could misinterpret some of our data unless we have beforehand drawn those figures in. Let's say it really is a valley, then we would need to connect a 3D line between those 2 points and say, okay, 110, you can't look across and see this 110 because this is in your way. Think about it in terms of, say, a curb structure. Surveyors go out and they get points A, B, C, D, E, F, G, and H. And then we turn it loose and let the triangles start to form. Well, if I'm sitting on A and I look all around myself, I can see point E, and I'm going to create that little line straight between A and E, which means it assumes the surface goes linearly from A to E, when really it comes down to the face of the curve and then it climbs up to E. But I didn't pre-draw this line in. I'm just letting the points go. So I could wind up with triangles that form like this on the other page here, where A can see E, but now A can also see point C and it can see B. So these edges are valid. They lie along that surface, but C, looking up here to the back of the curb, cuts right through the curb. So that's invalid. This one's invalid. So to prevent that from happening, you would take that same figure and you would pre-draw these edges that go along those structures. So now with them in the way, that prevents A from looking up here and see E or G or F or any of those. It can only connect to C and B. B can only connect to D and C and A and anything else down the line here. But it can't cross this line and connect up here to F. Same thing, D to H, G to C, that sort of thing. So those are our break lines. And that's really all that we need to model these surfaces. We need points and we need break lines. And sometimes we have points in the form of, say, surveyed points or points that we've created, whether they're Carlson points or otherwise. Sometimes, though, we don't have any of those points, but we do have the 3D geometry that's pre-drawn along those edges, and they have points internal in them. They have those vertex points, the vertices of those figures, and those serve the very same purpose as points. It sits on each one of those vertex locations. It looks all around itself in space. And if there's no barrier between where it can find another point, it will go ahead and form that edge of that triangle. And that's basically it. That's all we need to be able to come up with this information. But, and here's some example on page 22 where you can get some of this information, LiDAR, photogrammetry, other paper maps. And right here's something to always keep in mind is that you have to evaluate this data to make sure your surface is correct, because the computer will quite often run the command and it will say, hey, congratulations, you built a surface. And the surface could be completely wonky. So it's up to us to take a look at that surface and make sure it's doing what it is we want to do. Okay. So we're going to use a number of tools for that. We're going to use that drawing inspector where we can, hover over something and look at its elevations. We're going to use our 3D viewer that we're going to learn to use. And we're going to look at things like this. Now, this is a case of where the data looks good. The center of the stream looks like it's coming down in elevations. Here's the road edges are up and they follow the terrain. But here's what often happens in maps like this. Now, when you look at that map in plan view, all you see are these lines and points over here, but and you see these drawn road edges. And sometimes those road edges are down here at 0. They're not like this here. But we wouldn't know that from looking at it in plan. So when we look at it in 3D, we're going to see whether or not we need to have these brought up to their proper elevations or, because if they're not, and they're not going to be considered, then when I'm creating the terrain across this road, points along these lines can look straight across here and see points along this line, and I won't get the road edge and the crown of the road. I won't get any of those indicators. And that would be a case of like right in here where this road goes through this cut. So if that road's not elevated, points up here on the top of the cut can look over and find points along the other edge of the cut, and it will just draw a triangle straight across, and it assumes the ground is up there, and that might be a 40-foot cut in the roadway. We don't know that. And without drawing those edges and making sure they're there to prevent that from happening, we're going to get some invalid surfaces. We won't get an error. It's going to come back and say, ding, 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 here's your surface. And if we're not aware of what it's done, we're going to get some erroneous results. So let's take a look at some things, excuse me, that can cause this to happen. So I'm going to go back to Carlson. I'm going to close our little example work file. I'll be back here to my start screen. And this time I'm going to choose Open Files. And I'm going to navigate to my folder. I'm here in my Middlesex Training Data Sets for Civil Class. And I'm going to come down here. I'm going to find this one at the bottom called Sample from T3 Global. I'm going to say Open. And when that opens, you're going to see a drawing like this. Now, this particular drawing has a number of things in it that have actually been pre-done for us. This file is an actual chunk of data from an aerial mapping company called T3 Global Strategies. And it happens to be the interchange on I-76 at Breezewood on the Pennsylvania Turnpike, or not the interchange, but right near the interchange, one of these little commercial sites. Now we look at all this and it looks like a real mess. We see a bunch of these white, kind of scraggly looking lines. We see some contour lines, labels. We see, inlets, signs, lights, all of the different things that you associate with mapping. Here's some more inlets and posts and signs and such like that. Okay, so far so good. But what do we sometimes often see? And let's do this. What I want to do is another tool. I'm going to go to View, and I'm going to choose Freeze Layer by Pick. That's also on the Layer toolbar if you have that out. And so now it wants me to pick an entity on the layer to be frozen. I'm going to come up here in this right or upper left corner, and I'm just going to pick one of those scraggly white lines, and I'm going to turn that off. Okay. Those particular lines, the aerial mapping company provided as part of this data set, those are the break lines that they actually compiled from the imagery, and it was used for them to generate these contours. And so now we're looking at this. Sometimes this is what we typically get. Maybe it was a PDF and we've elevated it to, we put the contours at the right elevation and that's all we've got. And so we're going to go with that. But here's what can happen is we see a bunch of things here. We've got these drawn edges, these drawn curb lines. And if I select that curb line, I see that it is just a standard polyline, just 2D, and it has an elevation of 0. In fact, if I turn on my drawing inspector under inquiry, drawing inspector on and off, bring up my options, I'm just going to display, say, the layer name and the elevation, and I'll uncheck these others. And now as I hover the mouse over this, I see that's on a layer called V-road-curb, makes sense, but it has an elevation of 0. Here's one on V road outline, also elevation 0. If I hover over a contour line, V topo major 1295, 1294, 1293, and it stays that constant elevation. So I've got some things at elevation, some things are not. And right now, the only things that are at elevation are going to be what we see next. So let's go to the View menu, and we'll go into our 3D viewer. Now, this particular 3D viewer has 2 different entry points. We can choose the drawing viewer or the surface file viewer. It happens to be the exact same viewer, but it matters as to which one you select as to what it asks you to choose. So let's right now just evaluate our drawing. And so it's going to ask us to pick things in the drawing. So I'm going to go to my drawing viewer, and it says select the entities for the scene, then select entities. You can draw a window around it, or remember, you can type the keyword all and hit enter. And it still says keep selecting, but I'm done selecting, so I'll hit enter, and up it's going to pop into my 3D viewer. Now I see a number of things here. I see some spot elevations. I see a bunch of these little pink looking dots, and those happen to be CAD points. They're not Carlson points, but they are points nonetheless, and they are at elevation. And I can tell that because over here on my control panel, I have this switch check that says ignore anything at 0 elevation. If I uncheck that, you can see all that other stuff shows up, and it shows up, down there at 0. Now it shows up, it's not lined up with it here because we're looking at a perspective view. And if I look at this, there's my view. So I'm looking at it in perspective. That's why it looks smaller. Okay. So in this case, I want to always make sure I've got this ignore 0 elevations checked on, so I only see the things that have elevation. So I've got some contour lines, I've got some points, these little pink point locations. They're just CAD points, and it's hard to see them in the regular drawing file. I'll show you that in a minute, or we can fix that.
Excuse me, where did the view control come from?
The thing that I'm looking at here,
No, the one that's on your right.
you don't see this panel with the 3 tabs at the top?
No,
What do you see?
I see nothing. I see this page.
Okay, so go to the view menu,
Yeah.
3D view, drawing viewer. Then it will ask you to select the entities. Select.
It didn't ask me to select any entities.
what did it say? If you go to view, 3D
3D
view,
view, drawing viewer,
yep. What's it
and
asking
then
you on the command line?
start of line.
Start of line.
Yeah,
Anybody,
that's why I'm so lost.
is anybody else getting that? It shouldn't say start of line.
Drawing viewer says select entities. There it is.
Yeah,
Okay.
okay. So if you select your entities and when you're finished selecting, hit enter to tell it you've finished selecting, and then you should pop into this viewer. Now it could be on a different screen, it could be a different size, but you should see this and that should have the control panel. You get that now?
Oh, what entities do I select? That's my question, I guess.
Everything in the drawing that you see. Did you freeze off those white lines?
Did I? No, I don't think so.
Okay, so what does yours look like this?
Yes.
Okay, go to the view menu and choose
Okay.
freeze layer by pick, and it's down here about 2/3 of the way down.
Each layer by section.
No, by pick,
Oh,
right above it.
uh,
And now just pick on one of those white lines and that will go away. Now hit enter to finish the command.
okay.
Okay, now you should be seeing what looks like here on my screen, right?
Yes.
All
Thank
right,
you.
now, you bet. Now go back to
Appreciate it.
view. Yep. Back to view, 3D view, drawing viewer, and select everything in the drawing. And hit enter when you're finished selecting so that it goes into the viewer. Now I happen to have mine maximized here so that we can see it all. Okay. So now there's a number of controls, and we'll learn to use these as we go through stuff, and we'll get more, you know, information here. So on our view control tab, there's a number of tools, and you can say change the color by elevation. You can turn that on, and it colors them based on their elevation ranges, or you can pull that down and say none, and those are the original colors. And so that looks like, what I would expect this to look like. It's got elevation on these contour lines, and I see a bunch of points, these little pink points. Now those points are on, I'm going to go over here to my tools. I'm going to grab that arrowhead, and I'm going to hover over one of those pink points, I think. If I can get it to, I don't think I can. Well, I can't get it to pop up the display. If you double click, so you'd have to be right on the point and it's not finding it. But anyway, we'll talk about what those points are here in a minute. But now to be able to see everything that is showing at elevation, I've got this checked up here at the top to ignore zeros. So it turns those off. And so everything else that you see is at elevation. And you can tell that a number of ways too. You could go to your settings tab, and down here where it says bounding box, if you pull that down and choose box only, then everything that has elevation fits within that box. And if I roll this up, now I'll show you how to roll this up here in a minute so you can keep track of where you are. I'll turn my box back off. I'll go back to view control, and I'm going to hit this zoom extents button on the right. So here's what these controls are going to do and how we use the viewer. We've already talked about the ignore zeros, color by elevation. Now the vertical scale is another thing. Like you can exaggerate this vertical scale. It just stretches it. It doesn't change the actual value. So I'm going to put it back to 1. So that's what it looks like with no exaggeration. These other controls, this little blue circle and this yellow square, which you can think of as the sun up in the sky. And it's going to be, as we move it around, you see I'm down on the horizon. I'm up here at high noon. I'm going to sort of park it up here in my northwest corner. You'll see that in a little bit when we look at solid surfaces where we can color in the triangles. And you'll see that because that allows us to see shadows and things. But for right now, we'll ignore that. Now, all of these magnifying glasses, zoom in, zoom out, zoom dynamic, zoom previous, that can all be done with the wheel on the mouse, just like when you're in the CAD system. Press and or roll the wheel in and out, press and hold the wheel. You can pan the drawing. Now, here's how to spin this thing up in 3D and keep track of where you are. It's sort of a mind trick. So the tool of choice right here is going to be this second icon. Besides, again, these magnifiers in the hand, you can do with the wheel, but this second icon says switch to rotation mode. When you choose that, look at the cursor, bring the cursor back into the drawing. When I'm on the edges, outside of the mass area of the data, the cursor has a Z and a rotation arrow. But when I get over the bulk of the data, and it's not exact, but when I get over the bulk of the data, it switches to X, Y. And you see it's got up and down and left and right arrows. So that means that if you press and hold the left mouse button and then move the mouse around, it's going to move along those axes. Now the trick is to, over here on the right, keep that Y axis locked. Okay, that's why it's set here to lock. So I'm only going to allow rotation about my X-axis and about my Z-axis. But here's the trick to knowing if you want to look at something in particular. Let's say I want to look from over here. I want to look down into this little pond area and see what that looks like. So here's what you do is you get it in plan view. And if you have to go back and hit the plan view button, this zoom extents or the plan view, these two icons are essentially the same. One zooms out, the other one is like wherever you happen to be, it just puts it in plan at that magnification level. So now once you've got that in plan view, you've got that icon, here's the mind trick. You're going to say to yourself that you are standing in your driveway and you're looking at your garage door on your house. And this garage door is one that doesn't have those little articulated hinges in it. It's just one that rolls up into the house, just a solid door. So we're going to pull our mouse down to where before it changes to a Z, we're going to make sure it says X and Y, and we're going to click and hold the mouse, and we're going to push up. And notice if I push left and right, nothing happens. But if I push up and down, it does this. I'm holding the mouse button and I'm pushing this up. And if I get it up, I'm going to go back to let the mouse button up, go back down to get another bite of it. And I want to push it up to where I'm sort of, I'm really oblique. I've raised my garage door, not all the way up, but where it's sort of like this. Okay. And then let the mouse button up, put the mouse now down in the bottom where it turns into a Z cursor. Now click and go back and forth. And so you want to spin this thing around and get another chunk of it if you need to and get lined up with the feature you want to look at. There was that pond. I'm lined up with it. And now just point at it and roll the wheel. So that lets me look right at that pond. And if I need to go back and find, let's say I want to look down this roadway down those edges, well, I'm going to just zoom back out and either just spin it around and point to it like this, or if you need to, put it back in plan view, push your garage door up again, line yourself up, and then point to it and wheel the mouse. So you can see I've got this nice little crease of contours. There should be a nice little valley, little ditch right off the side of my road where this runs down, right? So when I'm looking at this data, if I had a problem, if I had some points that were sitting, 100 feet too high, I would see these purple points way up here in the sky. So that would tell me right away that I've got something wrong with my data that I need to resolve before I can successfully model that. But when everything looks okay, we're happy with it. Let's go ahead and exit. And that's this little door icon, or you can just close the red X in the upper right corner to close the viewer. And so now we've got some contours and we got those pink points. Now these pink points, can't really see them on the screen. If I draw a window around, I can select, there's 5 of them selected there, and there it says there's 5 points. Now those are CAD points, they're not Carlson points. Although Carlson points have CAD points as part of them. So how do we see this how can we see those points? And that's a particular setting. So it's on our settings menu and it's an IntelliCAD setting, and it is this thing called point style. So if I choose that, here's the default condition, and what we normally keep is this little dot. But any of these that we choose would be the symbol that we see for displaying the point. Now, it's not actual drawn line work. It's just a symbol that shows to you on the screen. I've got a column here on the left that has nothing. That's this one. It has a dot. That's what it is now. And those dots are just barely visible. I've got a plus, I've got an X, and I've got a vertical half of a plus here. On this column, I've got circles superimposed on the same left column. In this column, I've got squares superimposed on that left column. And then on this column, I've got circles and squares superimposed on these possible symbols. So if I choose this icon right here, and then you can change the point size, I'll run that up to 1, absolute or a percentage of the screen or a percent of blah, blah, blah. So I'm just going to choose this, run it up to 1 and say, okay. Now you can actually see, and that when I select that, if I select any part of it, it selects the whole thing up and it is just a point. But I've changed the way the point looks. So now I can actually see those points, more directly. And again, you can change the size, and you can, if you put them back to just the dot, you'd have to zoom in, and like I can't even see them on my screen here. I go way away. I see, yeah, there I can just see the little shadows of them down here. Okay, so sometimes you'll have points that you don't not aware that you've got points. So we do have points in there. And if I look at those and I see they're on a layer called V Topo DTMP, V means surveyed, topo it's a topographic information, and DTMP means it's part of my digital terrain mapping point or my data point. And they were used along with those squiggly white lines to build this contour map. Okay. So, but what we're often given, and I'm going to freeze those points. So what we're often given, and I'm going to go to my view, freeze point, this time not by pick, but by selection, so that I can draw a window around it and make sure I get a few of them. It found 17. I'm good to go for that. And now, sometimes this is all we're given. It's just a drawn map. So I'm going to go back into my 3D viewer. And now when you see it, those points are no longer displayed. I just have some spot elevations and some contour lines. Now that's enough to build a surface, okay? And sometimes it's what we have to do. But that surface is going to, even though it's not going to give us an error, it's going to give us all kinds of problems. We're going to get, well, here's a case where this point is giving it a little bit more definition for this interior, so that would be okay. Same thing here. Where was that? There's a contour line right here that comes down here and walks around this feature, and it's got a spot in the middle, so it's raised it up a little bit there. So that's sort of helped define it with those spot elevations. But what's going to happen over in here when the only thing we have are these contours? So, and to sort of get rid of this false sense of awareness of everything that's showing here, because most of that stuff is at zero elevation, we're going to go back to another view technique here, and we're going to say view, isolate layers. So on the view menu, about 2/3 of the way down, isolate layers. It's going to ask us to select entities, but the line above says select the objects on the layers that you want to isolate. So what I want you to do then is zoom in, select one of the index contours, one of the contour elevation labels, if you wish, one of the intermediate contours. Now that has the main contours, but over here in this obscured area, there's two more sets of contour layers. So pick one of those, the yellow one, and then the green dashed ones, and hit enter. And now, sometimes this is all of the elevation information that you can derive out of a set of paper drawings. And you have to try to build a surface out of that, okay? So if I look at that, I'm gonna select it, go back to view, 3D view, drawing viewer. And I look at that and I spin it up and I say, well, you know, that looks like what that ground probably looks like. Okay, it looks pretty good. So I'm happy with that. But what happens right in here? As we talked about, when I come down this line, I'm hitting each point and I'm looking around myself. I'm going to look over here and I'm going to see that same contour line doubling back. And I'm going to say I'm going to connect a line across there. And so I'm going to make that a flat triangle. It has the same elevation as the contour line from which it was created. Same thing might happen in here and in here. Same thing would happen up here and right in here. It would just look across and start making those flat triangles. So let's go ahead and do that. So make sure you've got your layers isolated to where you've only got the contours showing. And if you need that, it's under view, isolate layers, and pick one or more. You can just draw. You're giving it examples of the things you want to isolate. So pick one of the index lines, one of the intermediate lines. You don't need the text. You can get it if you want it. And then also make sure you get one each of these broken contours in these obscured areas. So now your drawing should be nothing but contours, because this is often what we get when we try to elevate a drawing. We bring the contours up to elevation and we say, okay, good enough, let's build the existing ground. Well, here's what happens. Let's go to our surface menu and let's choose triangulate and contour. Now, this is a command that will build the triangulation It can also draw the contours, label the contours, and we can restrict the selection to certain things. But what I want to do right now is let's look at the selection tab, make sure nothing's checked in these first three boxes. Look at the contour tab and make sure it is unchecked to draw the contours. We're not going to draw them. We can draw the contours anytime we want as long as we have that surface file built. Okay. Now that's going to make our labels tab completely grayed out because we're not drawing any contours. And then back to the triangulate tab. And what I want to do here is make sure you write the triangulation file and then choose the select button and let's give it a file name. We're going to call it EG from CTRS only. Existing ground from contours only. We'll say save. So now you see the 10 file name has been defined. And then I'm going to uncheck everything here, and under my shrink wrap perimeter reduction, I'm going to leave that as none for right now. Erase previous contour entities, I'll leave that as off. I will ignore zero elevations. Now that's an important switch so that even if you have not isolated the layers that everything's on, if you should happen to select something that has zero elevation, it's not going to be used to build the surface. Otherwise, you'll get all those little table legs that jump all the way down to zero. And then I'm going to uncheck everything else. So I'm going to check to write the file, ignore zero elevations, and my shrink wrap perimeter reduction is set to none. We'll learn about that in a little bit. So that's all I need. I'm going to say OK. And it says on my command line, select entities, but read the line above it. It says select the points and the break lines to triangulate. Because remember, that's all really the data is. It's a bunch of points if they're isolated, or it's three-dimensional line work. Those are our break lines if they're pre-drawn. So in our case, our contour lines are going to serve as break lines. So now it says select everything you want to triangulate. You can draw a window around it. You can type the word ALL. I'll just draw a window, click, and hit enter. You see some things fly by on the command line, and it says auto saving open drawings command is back. So something was done. If I look down here, I'm going to click and roll up, and I see writing the triangulation file, EG from contours only.10. So everything worked, right? Success. I've got a file. But let's take a look at that file. Again, to the view menu, 3D view, and this time instead of the drawing viewer, let's choose the surface file viewer. And instead of asking us to pick things in the drawing, we're going to pick things from our surface file list. So that's going to be my recent files here, e.g. from contours only. I'll say open, and up it comes. Well, it looks sort of like it, right? I see the pond over on the right. I see basically the hint of the roadway.
Right. Ken, one question.
Yes, sir.
Where did you grab the surface file that brought you to the screen? Was that under surface?
Yeah, view.
I'm sorry, view.
Yeah, that's what this viewer, and it's going to be so important. And in fact, I use it all the time. And you see these two icons. Here's another thing to point out when you're learning the software. When you see a command that has an icon beside it, that tells you that it is on a toolbar somewhere. It doesn't tell you which toolbar, but at least it tells you that it's out there on a toolbar. And I can see that icon and that icon are right up here on my Surface toolbar. So in terms of toolbars, it's on Surface, but under commands, it's View.
Okay. Thank you.
Yep. So my Surface file viewer, I get my file, and here it is. Now, yours could look like that, or it could look like that. Notice what I clicked over here in the right-hand side is this little thing that looks like a fishnet. And so all of these little triangles, excuse me, are the triangles that formed from reading those contour lines. Okay. So, like I said, I can see certain things like this pond and this pond, they look okay, but I've got a little goofiness going up here, got some stuff here, but I don't see any kind of definition in terms of curb lines or anything like that. And in fact, if I zoom down here and look at this area, let me zoom it, let me roll it up and get lined up. And let's look down that, what should have been a nice smooth ditch. You see, it looks like a bunch of stair steps. Same thing over here. And if you need to reposition the light source and, cast different shadows from different directions, you can do that by grabbing that little yellow square in the blue. And so I can see right now that if I were going to try to go out there and let's say I'm building this road through here, when I calculate my materials, to come down here, it's going to compare it against this surface. It's going to hit an area in here that's too high, and it's going to give me some faulty numbers. Now, the interesting thing about volumes and surfaces is that in a case like this, where you've got a really bad surface, even though we got no errors and it sort of looks okay, in some of these areas where you've got things that are too high, they tend to balance out with other areas where it's too low. So when you compute volumes on a whole across the site, and sort of on average, the law of averages is going to say that, okay, you got overages in some places, you've got underages in other places. So it's going to sort of give you a not terrible set of numbers for your volumes. However, imagine if you were trying to build that as a curb structure or a ditch or something like that, and you drive your dozer down this line, it's going to go, chunk, 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 all the way down, chatter your blade on your dozer so bad you knock your teeth loose. Plus, I see some things over here too that I see this area in here, this sort of looks like a loading ramp or a ski jump. And I happen to know this site, and I know that that's a vertical retaining wall. That's a loading dock through there. Well, if I were to try to compute volumes in here, look at that chunk of dirt in there. That's going to be quite a bit of error. And I see, over here across the street, I just got a bunch of stuff that I can't really even distinguish what it's going to look like. However, we successfully built the surface. And a lot of trainers will say, hey, congratulations, you just built your surface. Next step. No, you need to know how to look at this stuff and how to figure out how to fix it. So let's go back out of the viewer, back out into the drawing, and let's go to our surface menu. I think if I can draw, yeah, and I want to draw the triangular mesh. And this is going to draw into my drawing now those triangles that you saw in the viewer. So if I do that, I'm going to choose the file. And I'll just take the default. I'm going to do this as just lines. And I'll just take the default tri lines as the layer name, and I'll hit OK. And after a minute or two, after it reads all of those triangles, it's going to draw them into the drawing. So these are the triangles that are formed. Now, there's a couple of things to note about these drawn triangles. Look at these out here on the edges, these long, skinny triangles. Same thing down here on the bottom. Now, if I'm going to pick one of those lines, and I'm going to right-click the mouse and choose Select Similar. And then I'm going to right-click the mouse and choose Draw Order and send them to the back so you can see the contour lines that it used to form those triangles. They're now on the front. So here's a triangle. If you look at this contour line as it comes along here, I'll select it so you can see the grips. So when it sits on that point, it looks all around itself and it starts drawing these lines in. Comes up here, looks around, and it says, I can look over here and see this point. Well, that point is the same elevation as the point I'm sitting on. But really, the elevation in here should be about halfway between this contour line and this contour line. It should be about halfway, but it's not. It's flat. It's all that same elevation. And those are what are called flat triangles. Now, these triangles out here are invalid. However, they were formed because when I looked at this contour line, it set on that point, looked all around itself. Well, it looked way up here and it saw a point up here. And so it drew that line in. Same thing down here. We don't really know anything about the surface in here. It's just creating triangles because there was nothing to keep that from happening. And that is what we need to do, is to put a boundary on our surface. Okay. And those are just going to be plain old polylines. And there's a number of ways we can create them. And we're going to learn about that now. So if you've drawn your triangles, you got them in there. Let's get rid of them. You can either select one, then select similar, then delete them, or let's go to the edit menu and choose erase. Let's erase by layer. So we choose that command and then up pops our little dialogue, and we can either select them from the screen or from a list of names. So I'm going to select my layer from the screen. I'm just going to pick one of those pink triangle edges and hit enter. So it now identified the layer, put it into our list. I'm going to say all. So everything on that layer is going to get erased. I'm going to say okay. And after it reads it, it will get rid of them. So if I don't want triangles to form, say, from the corner of that line up to the corner of this line, I need to have something in the way so it can't look across to see it. And you can do that a number of ways. I'm going to go to the View Layer Control command. And I'm going to create a layer here called, I'm going to go up here and find my new, say new item, and I'm going to call this one SURF-BDY. That's going to be my surface boundary. And I'm going to set it to be red, and it's going to have a weight, a line weight of 0.5 so you can see it. Okay. So now, if I do nothing more than this, if I just simply draw a 2D polyline, and I'll uncheck that, and I'm going to select the layer, which is going to be that surf BDY. I'll say okay. Now I'm just going to start drawing here. I'm going to pick a point here, come all the way up to here and say maybe pick this point, and then maybe come over here and pick this point. Come up here and maybe stray across here to there and come down to the corner. Maybe come down here to the bottom. And maybe come up here where I see my data is. And I'm just going to type C to close. C to close. So there's now my figure. Now that is going to be used as an inclusion-exclusion boundary. And here's the effect it will have. Remember the triangles we saw were all the way out of here in these long, skinny triangles in these areas. But if we have a polyline drawn in our drawing, we can go back now to surface, triangulate and contour, Leave everything just like it was, and it's going to prompt you to overwrite the file. That'll be okay. But we're going to come down here and say use inclusion, exclusion areas. And it's going to have several ways we can trim that surface. We can either trim it at the boundary, or we can remove any of the triangles that cross it, the entire triangle. Well, we're going to trim it, so it's going to crack the triangles and put the edges on them. So that's all I'm going to do with that, is use the inclusion, exclusion area. I'm going to hit enter. Okay to overwrite. Yes, it is. Now it says select entities. Now don't get in a hurry. I can't tell you how many weeks it took me to get past this. It says select entities, but because I clicked that switch, it doesn't want me to select the things I want to build the surface from. It says select, read the line above. It says select any inclusion perimeter polylines or enter for none. So I'm going to select that red polyline that I drew. I'm finished selecting my inclusions. I hit enter. It says now select entities, but again, read the line above. It says select any exclusion polylines or enter for none. I don't have any, so I hit enter for none. And now it says select entities again. So select points and break lines to triangulate. Now I can get everything. And because that polyline I drew is at 0 elevation, it's going to get ignored. And so it's going to go and build my surface. Now let's take a look at that surface with our viewer. So back to view, 3D view, surface file viewer, this time EG from contours only, but you see how it has clipped out those long skinny triangles. Okay. Something else that you can do, I'm going to select that I drew and get rid of it. I'm also going to turn my drawing inspector off. I noticed it was on. So now I'm going to do this. I'm going to draw a 2D polyline, and I'm going to do this. Now it has to be closed, so I have to say C. I'm going to draw another one here. And I'm going to draw one more, and let's make it yellow. All right. Let's go back to triangulate and contour again on the surface menu. Leave everything exactly like we had it. Just say okay and confirm that it's okay to overwrite. And now it says select any inclusion perimeter polylines. Notice it's plural. So if I select one of my red ones, I select the other red one, I'm through selecting. It tells me I've got two things here. I'm through selecting, so I hit enter. Now select entities, ask me to select the exclusion polylines. Again, could be plural or enter for none. So I'm going to select this yellow one. One in my selection set, I hit enter. Now select the points and break lines to triangulate. Off I go. It built the surface. I'm going to view the surface one more time. My surface file viewer on the view menu, 3D view. Select it, and you see a little preview of it over here. I say open, and there are the things that were included. Now the exclusion, I didn't really show a good example of that. I should have done that so that it crosses these. That's what I should have done. So now if I triangulate and contour again with nothing changed, select my inclusions. So that's the only place it's going to read data and build a surface from. And then it's going to exclude data within this. Now select all my data, build my surface, view my surface, and there you can see the results. So it only got what was within those perimeters, and it excluded the things that I said to exclude. However, it's just one surface file. That's all it is. And it just has undefined areas within it. Okay. So what that's useful for is, let's say you've got a big site, you've got a big existing ground or something, but maybe you're working up here on phase 1 or phase 2, or you want to create little subsections as part of that surface. So that's what that's useful for. What's another example of exclusion polylines, for instance? How about building footprints? Because we don't know what's under the building, right? So if let me look at my layers here, my view layer control, and I'm going to find this V building outline layer, and I'm going to thaw that. So now I see these building outlines that I'm going to use. And I see that I select it. It's just a 2D polyline down at elevation 0, but that's okay because I'm just going to use it as a clip. Now, if we did not want to draw that boundary around there ourselves and try to figure out where everything goes, there is a command called shrink wrap entities, and it's on our draw menu. And it's right here called shrink wrap entities. And when you choose that command, you go to draw menu, shrink wrap the entity. So what it's going to do is it's going to look at everything we select, and it's going to basically shrink wrap a boundary around those things. And so here's how this works. If I say shrink wrap entities, there's two methods. I can go across gaps, or I can say bounded line work only. We'll get into an example of that maybe later on next week. But we're going to go across gaps because we want it to jump across these endpoints along these contour lines, but not run inside to try to find some boundary. So we're going to go across gaps. We're going to give it a maximum gap value of, I don't know, 50 feet's probably okay. And we're going to select the layer name, and I'm going to put that back on that surface boundary layer so you can see it. And for this perimeter reduction right now, I want you to set that to none and choose 2D polyline. Choose OK, and then grab all of the data to shrink wrap. Hit enter to finish, and there is the result of it looking at the gaps. Now it looked across here, and that's probably bigger than 50 feet. Let me see if I look at my distance from here to here. Yeah, that's 76.05 feet. So if I wanted to do that differently, I'll redo draw shrink wrap entities. I'm going to change that. Let's call it 150 feet as the maximum allowable gap. Well, heck, let's make it say 200 feet so it jumps across here. Leaving perimeter reduction as none, and I'm going to grab all my data. And now you see it didn't come inside here too far. Now, what it did, I could, just go with this. I could even select this and maybe say convert that to an arc and maybe put a nice smooth circle up there, whatever I wanted to do. But here's how to understand what that command is asking when it's talking about perimeter reduction. Okay. When it tries to draw this shrink wrap boundary, it looks at all the data and it actually builds a surface really fast inside its memory. And it had all of those long, skinny triangles out here like we saw the first time we did it. And then it says, well, of all those triangles that it did out there, now let me Try that one more time here. And let's change this up to, say, 5,000. Yeah, there we go. So see, all of these skinny triangles have been computed in memory, and then it goes around and it finds the outermost triangles and it traces their edges all the way around our site. But we still have these areas in here that we want to get rid of. And so when it says perimeter reduction, and we said none, it was as if we had drawn those skinny triangles and we said, don't get rid of any of those around the perimeter. If we change it, and I'm going to select this and delete it, I'm going to repeat my shrink wrap polylines. And instead of none, I'm going to say high. I want you to go around the outside several times, find those triangles and start reducing them and do it at a high rate. So now when I do this and select it, you see what it's doing is it's coming around here and it's finding that long skinny one, gets rid of it, finds the next one, the next one, the next one. Same thing up in here, and it just sort of fractures down to where it finds the edges of these drawn lines. So what used to go straight across here has now, where those triangles were in here and there's nothing there, it has reduced those and given us a boundary. Now that boundary would certainly work. However, what you're after, what you really want to try to do is come up with a reasonable facsimile. So I'm going to set my maximum gap to 200. And instead of a high reduction, I might look at a medium or a low reduction. Let's look at low first. Take a look at that. And we see, okay, that's cut up in here and got rid of those. It's cut up in here, got rid of those. It's a little bit out in here. I might want to actually try to just interpolate some data in there. And you could do that a number of ways. You could, select your polyline and just manipulate these data points till you get them up like this, get them off that. And you see those little kind of choppy looking things. You could do the same thing there. You could say, get rid of that one. I'm just hovering on the grip and saying, remove vertex. Okay, so you see that's now incorporating more of those. And I could do that all the way around. That would take me a good while. Or a quicker way, the Carlson edit command. So on the edit menu, polyline utilities, and it's under remove polyline, and it says remove polyline vertex. Now this is a much faster way of doing that than grip editing. And I see there is an icon next to it. It's on a toolbar, and it happens to be on my polyline toolbar, which is up here. And it's a picture of a pencil eraser over top of a red vertex. So I'm going to choose that. I'm going to choose the polyline. And it's going to flag for you where all these vertices are. Now you're just going to go through here and you don't have to snap. You just click nearest. So whichever one you're nearest to, it's going to get rid of. And if I do in here, for instance, get rid of that one, it puts the grips back on. And I'm just sort of taking out some of those stair-steppy looking things. Okay. Now, I would not go nuts in trying to do that in this regard. I would just let the thing, be what it is, say with a low reduction. Maybe, trim that kind of stuff up. And that's perfectly fine for my inclusion boundary. Okay. So now if we go back to triangulate and contour on our surface menu, triangulate and contour, again, keeping everything like it was, confirm to overwrite, select the inclusion, which is now that red line. I'm finished with the inclusions. I hit enter. Now select the exclusions. I'm going to select these buildings here. And get this one in the corner. Now, I'm not going to select this one because in my mapping that says ruins. That's just an old concrete pad and there's a contour that runs around it. So I'll leave those. I've selected my buildings for exclusions. I'll hit enter to finish that, and now I'm going to select everything to build the surface. Off it goes, builds the surface. I look at my surface in my view, 3D view, surface file viewer, and I see that, well, yes, indeed, I now have those clipped out areas, and my triangles are cut out of those areas that I had on these edges. So that's how we use those boundaries. Now, that being said, if I erase that, and I'm going to go back to triangulate and contour one more time. And this time, instead of use these inclusion exclusion areas, I'm going to uncheck that. And it's going to allow me to shrink wrap perimeter reduction. I'm going to put that back to low, but I'm going to hit the setup button. And I'm going to say, yeah, I want to draw them, draw it as a 2D. And I'm going to put it on this layer that we had set up called surf boundary. Now, it didn't give me a chance to stipulate a gap, but we're going to see what happens with it here. So it's going to actually do the shrink wrapping for us. So I'll say, okay, now it's not going to, and then I'll say, okay, confirm. Now it says select the entities, but it says select the points and break lines to triangulate. So it's going to be everything I select here. It's going to shrink wrap it for me and it'll draw it, but now it won't come up with those exclusion areas. So this is the resulting automatic shrink wrap reduction as if I had drawn it and not done any edits to it and selected it. And if I look at that now as that surface, you can see the results of it, but I don't have those exclusions. So when you have the opportunity and you have these things that you know are exclusion areas, you want to always, let me select, you probably want to always pre-draw the boundaries. And when you run triangulate and contour, instead of letting it do the shrink wrapping for you, you want to use inclusion, exclusion areas, and it will prompt you to pick them. Okay, but you have to pre-draw them first. Okay, so that would be one aspect of that. So I'm going to pre-draw that just like we had before. Say, okay, get all my data, let it come up with that. I can use that. And, you might stream that out a little bit, maybe erase polyline vertex, and maybe just get rid of some of these across in here. I wouldn't worry about those. I'm just going to leave those. I'll finish the command. So I'm now all set up to make that surface, triangulate and contour. Oops, sorry. Surface, triangulate and contour. And I will use inclusion, exclusion areas this time. I'll select my inclusion boundary. There's only one. Then select my exclusions. I'll get these buildings. Leaving that one alone. And now select the data. And now viewing it, I'm back with things like they were. But now I still haven't fixed this issue here with these little stair steps along those contour noses, right? So how do I do that? Remember I told you those, when I drew those triangles, those are called flat triangles. Well, I have another switch that's available to me when I triangulate and contour. So I'll go to surface, triangulate and contour, leaving everything alone here. but I'm going to come down here to this section that says adjustments for source data of contours, and I'm going to minimize flat triangles. Now, it's not perfect, but you'll see it does a much better job. I'll say, okay, yes, overwrite, select my inclusion, select my exclusions. Finish that selection. Now select all the data. And off it goes. It wrote the file. Let's take a look at it and look at that down the road edges. I think you can see right away it's much better at defining that. There's still some places over here on the right-hand side. You can see over in here, that's not all that clean. Okay, but it did as best it could. I still got these little goofy areas here. I've got that, spin this around so you can see it. I've got this business over here going on. So what can you do to resolve that? So if all you had, and I'm going to put all my layers on and I'm going to freeze those lines there. So if all I had were these drawn contours and I had these drawn lines, like right here's this retaining wall, but it is at 0 elevation. So I could make that into its 3D equivalent by where it crosses these contours. And then that would serve as a break line. So I'm going to do that one particular thing. So to set yours up, go to the view menu and choose thaw/on all layers. Okay. And now I'm going to take that one boundary there and get, well, no, I'll leave it on for now. Notice it's brought inside about 50 feet because they compiled all this data, but when they delivered the file, they only drew the contours up to the outside edge. So they trimmed off the outside stuff, which is a little less accurate than the inside stuff. So I've now got everything on in my drawing. I'm going to choose view. And I want to freeze layer by selection. And I'm going to come down here to the bottom and I'm going to pick one of those 3D polylines. And then I'm going to click a little window in here so I pick up some of those points. And I see here that it did find 6 entities. So that's good. I'll hit enter. And so now those white lines and my points are gone. And I'm back to this. And so one of the things that we could do to make that little ski jump go away and turn this into a 3D break line, we go to our elevate menu and choose 2D to 3D by screen entities. Okay, so let's choose that. And we're going to ignore zeros. We will extrapolate any end elevations. Keep the existing polylines, and we're going to put this on a layer, the resulting elevated line on a layer called 3D break line. And we'll check on to use elevations of other proximity entities with a maximum offset of, let's give it, say, 3/10. That's fine there. And I'll say, okay. So now it asks me to select entities. Reading the lines above, it says select the polylines to convert. Well, that's the only one I want, is that red wall. Okay. Now it says select any 3D faces, lines, and polylines that have elevation to set the elevation of that feature. So I'm just going to zoom out here a little bit and I'm just going to do a little crossing so I make sure I get everything. I could type all, because if it doesn't intersect it, it won't use it. But I've got everything selected now that I need. I'll hit enter. And there now is my new 3D polyline that is going to serve as my break line. In fact, if I were to look at this in 3D just to verify. I'm going to select just a few of them, look at it in my 3D space, zoom this around, and I see, oh, okay, so that's going to cut out that one area where we had points up in here on these contour lines that were looking way out here and connecting to other contour lines. This is now a barrier that's in the way to keep that from happening. Okay. So now let's take a look at our surface. We'll go back to surface, triangulate and contour, everything exactly like we had it. Say okay, yes, overwrite, select our boundary. We're finished with those. Any exclusions, that's where we need to get our buildings. And now select the points and break lines to triangulate. And it's going to be all the same, which is just the contours. And now this one area. Off it goes. Let's take a look at that surface file now. View, 3D view, surface file viewer, same file name. But notice the difference up there where that little ski jump was. It's now modeled because it got in the way of these contours up here from seeing these contours down here. Okay, so that's what we would need to do when we recognize problems and we don't have anything else. Now I'm going to select it and I'm going to get rid of it, put it back to the way it was. And we're going to talk real briefly now about the way this is really supposed to work here. Is what is a contour line? What does that represent? And how do you think these contour lines were created? And the answer to that is that they built a surface with a bunch of triangles on it, and then they looked at that surface and let the computer decide where these lines cross the edges of those triangles at that particular elevation, and it connected all those edges up. So in other words, the contours are actually an output of a surface. They should not be used as an input to a surface. These contours are simply a means of representing that surface in a form that's familiar to us. They don't really define the surface because they don't define anything in between the contours. What defines the elevations in between the contours, and if we turn our layers all back on, go back to view and thaw on all layers, it's all of these little edges, these white lines. And let's go to view and isolate layers, and let's pick one of the little white lines and say some of these points. And now that is the data, and you see it's got these curb lines. They have some elevation to them. And if I view that in my viewer, drawing viewer, and I select everything, I see here, and it's these white edges and those pink points are what was actually used to generate the contour lines that you see when I go back here to now view, restore layers. So these contour lines were created after the surface was created, and they are interpolating the surface. They don't define the surface. It's just these white edges that define the surface and those points. So let's go back to one more time, and then we got to put a bookmark in it. Let's isolate the layers. Let's get one of the white lines. Let's get a group of these points, and let's get our red boundary line. And our building outlines. And so these are going to be, now let me change that layer of building outlines so you can see them a little different from the surrounding white lines. There we go. So now I'm going to select this boundary. I want to go out here and grab the rest of this data. So I'm going to delete that. I'm going to redraw my shrink wrap, and this time come around all the data. And there we go, it looks better. And you're going to see something really neat when we do it this way. And you could do, any of these kind of little manipulations that you need. So let's now go and choose surface, triangulate and contour. And this time, instead of using that same file name, I'm going to hit the select button. And I'm going to call this EG from BRKLNS and PTS endpoints. So existing ground from break lines and points this time. Okay. I no longer need to minimize my flat triangles. I can do a little densification here internally in memory so it adds extra points if it needs them. I will use inclusion exclusions, ignore zeros, and I'll say okay. And so now reading the prompts, here's my inclusion. Any exclusions, I'm going to grab my buildings. And now select the data to triangulate. And it built it. Now, it did identify a couple of places where there were some errors here, and I'll show you what that is. When I select a given spot, and let's zoom to it and then zoom in, there's a head wall structure here where they've crossed their break lines, and that's a no-no because it can't tell which one to use, which elevation to use. We're not going to go through resolving that, but normally you can either just ignore them, or if you really need that, you need to ask them to fix it, or you would just select it, maybe, move that, move these things to the inside and the other thing to the outside, whatever you wanted to do with it, okay? So you could resolve it in that fashion. All right, so now, even though I identified the errors and we didn't really fix them and redo it, let's take a look at this surface. Let's go to view, 3D view, surface file viewer, and let's use the one from the break lines and points. Now I want you to take a look at the difference. Look down this road. Look over here down that road. Look up here at those curbs. Look over here across the street at the curbs and retaining walls. Curbs, really, really nice definition. There's that retaining wall back here that was part of that little ski jump area. I can see a little sidewalk around my building, and it has a curb on it. And, I can even, if I get in here tight enough, you can see that that curb is, in fact, a wedge curb. It's a little triangular curb that just lays back. It's not a little 6-inch block curb. But that now is the file, or that's the resulting surface from all of that break line data. Again, you can change your shadows, etc. Look at your ponds. You've got the thalweg of that stream is very nicely defined. Nice sharp edges because they compiled those as that, all those little white lines, that's the break line data. That's part of that surface. Now, right in here is that little goofed up head wall area. All right, so you could fix that or not, but that's about as good an existing surface as you can possibly get. And I'm going to go to my settings tab. I'm going to display my contours, and you can see that's what those contours should look like. And if I go back to my, I'm going to go to model, and I'm going to choose, whoops, I don't have my contours displayed. If I were to look at these with the drawn contours that they delivered superimposed, you see these contours are doing this. Whereas if I look at my old surface contours only, and I draw the contours, I did the wrong one again, sorry. If I choose from contours only, and I draw the contours, you can see over here, see how they sort of blew up the contours here where it has these little bad spots in it. Okay, so those are some of the tools that we need to learn to use. We need to shrink wrap our data to limit it. We need, if we do have to build a surface from the contours, we want to make sure on our triangulate and contour dialog that we minimize flats. Okay, you don't want that on unless you're taking it from contours. Okay, so and also understanding that if you can find a layer or something in the drawing where these are drawn, that's the data to use, not the contours. Okay, so just, don't rely on the fact that you get through a command where you say build a surface, because it could be completely poor. Now, here's one where I still had that wall got defined there, and I can add to that my other surface, and then you can see if I turn that off, let me turn off my contour lines. But look at the difference right in here, for instance, between the surface from the contours versus the surface from the break lines. You see the extra definition? That's going to give you much better volume reports and a much more accurate surface. There we go. So using those techniques and those tools and the awareness of what you have data-wise is going to help you really fine-tune your modeling process. All right, so we'll take a look at that next week on some other concepts on, some of these compromises and how we might have to take contour lines. And sometimes, again, like I said, that's all we have. But what are the techniques that we can use to help streamline that data? And one of those would be knowing that in places like these nose contours, we need to take these lines, convert them from 2D to 3D by screen entities where it crosses these and it gets those elevations, and that can serve as a break line. Okay, so if you have these things drawn, but they're 2D, consider elevating them so that they're 3D, and that becomes much like this example right here, where we had these edges, these road edges were drawn in 2D, And if we elevate them, we're going to wind up with something like this that will serve as brake lines and really sort of fine tune our surface work. Okay, so everybody good with those concepts? Everybody, again, I know it's sort of like drinking out of a fire hydrant, so don't try to think, you're going to know this overnight. Just let it sink in, and um, we'll pick this back up next week. Any questions while we're wrapping things up then? Everybody good?
Ken, I'll ask one generally if nobody else has one. You suggested that we do this day one and then have kind of a layover till next week. I mean, is there something that would be beneficial for the group to do between now and then? Or is there a
Yeah.
reason why you do that more so than others? Or
Well, part of it was for schedule wise, but it's also, I didn't want to take people out of production for 3 days straight.
okay,
So, so that's really, one of the big reasons. Plus, there's a lot to absorb, a lot to sort of take in. We've gone
Yeah.
through a lot in a hurry. And so what I would recommend is that you take a look back at your manual and go through some more of these other exercises. And there's one really good one here. We talked about points and point groups, adding brake lines and surface tools that we just got through doing. But look at this exercise called putting it all together and see if you can step through that particular exercise on your own. And it's basically building, we got a bunch of points that define a stockpile. We cut a borrow pit into it and then define a little haul road, that lets you drive into that borrow pit and then, put all those surfaces together. And we'll maybe start off next week with doing that as an exercise so that we can reinforce some of the things we've learned today and get sort of back on our feet with thinking in 3D. Okay. So that last little exercise called putting it all together would be, if you get the opportunity, go through it. And if you don't worry about it. We'll pick it up and address that next week. Okay.
yeah.
Hey,
Anybody
Ken,
else?
is it safe to assume that we'll have access to these recordings as well when all is said and done?
Absolutely.
Okay.
You'll have those. In fact, what I do is I post them up on my YouTube channel and then send you the links, and they're private links. So nobody else can see them, but you in the class. And then you can just go to them anytime you want them and step through them again. Now, I will be sending out another data set for next week that's really more geared toward the PDF conversion process. And so we'll combine that with what we've been doing here. So, okay.
Yep.
Also, Ken,
Yes.
can we, is it in your agenda to cover some like unsuitable excavation or over excavate surfaces? Or in other words, is subsoil excavation?
Yeah, so if we need to define areas of over excavations and all of that kind of stuff, then yes, we'll do that.
Yeah, it will be beneficial for us, I think.
Yeah, no, yeah, we'll certainly do that because there's areas, once we get into the takeoff methodology, where we define those areas and it adjusts the amount of earthwork that occurs within those regions. Okay,
Yeah.
right. Well, with that, let me stop my sharing here and I will stop my recording and